so that at any time, if you want to have access to what we are doing here, you can. Also, you should find a course materials section. In the course materials section, you have access to the course materials. So what you can find in there is two slide decks. Slide deck lesson 7 and a slide deck lesson 8, which are all about OpenShift. A little bit of background. I am currently developing a new video course for EX280. And before I was just producing the video course and then started selling it. And in this video course, this is the second time that I'm doing a couple of trials. And that's for the simple reason that OpenShift is complex software. And I want to make sure that everything is working. So that is why today we are doing this advanced workshop. Workshop means that I have a couple of lab exercises for you, and you can work on these lab exercises. And I will provide my introductions. And if at any point anything is not clear, then please do let me know. As far as in the development cycle, I have put a lot of effort in optimizing the lab exercises. There is one of these lab exercises that is known to be buggy. The other ones should just be working. So that is what to expect. Also, we are working for a total of 5 hours today. That means until 7 p.m. Amsterdam time. That can be something else depending on where you are. And on top of every hour, more or less, we will take a break. That will typically be a 12-minute break for the simple reason that I like 12-minute breaks. All right, I am going to share something now. I am going to share access to my presentation. So what you can see right here is my PowerPoint presentation. As I do expect some minor typos and stuff to occur, I like sharing you the PowerPoint. And when I discover something that needs editing, I'm right here in editing mode. Again, you can find the presentations in the course materials section, so you can work on what is in there all for yourself. Okay, lesson 7, that will be the first half of what we are doing today, is about networking and networking related stuff. Lesson 8 is about scheduling. And let me just lecture what is in there. So OpenShift networking, what do we see in OpenShift networking? Well, in OpenShift networking, the first resource that you are going to work with is the service. The service is a Kubernetes resource, and it provides load balancing to replicated pods in an application, and services are essential in providing access to applications. And services connect in Kubernetes terminology to the endpoints, and the endpoints are individual IP addresses. Ingress is the Kubernetes resource that exposes services to external users. And in order to do so, Ingress adds URLs, load balancing, as well as access rules. Ingress is not used as such in OpenShift. In OpenShift, routes are the primary alternative to Ingress. And routes is what you need to learn about. Also, if you are going to prepare for the exam, the EX280, then you'll definitely have to work with some routes as well. Let me see, somebody just joined or not. Okay, that was just me imagining. Okay. For your information, I might host another session in a couple of weeks with a sample exam in order to work you through the sample exam. I do appreciate if you can let me know in chat if you are interested in exam, if that's something that is relevant for you, or if you are just here for the knowledge. All right. Let's talk about Openshift Sdn. Openshift Sdn is OpenShift software-defined networking, and I would like to explain a little bit what that is like. Well, that's good to hear, Rob and Robert. At least there will be three of us. Keep an eye on my social media. I will post in social media, newsletter, LinkedIn, by the time we are going to do that exam. Hey Santos, nice to have you here as well. And wow, I think that means that participants from the African continent today in this course is bigger than from any other continent. We have Zambia, Kenya, South Africa here. That's cool. Right, let's continue. Let's talk about OpenShift Sdn. Sdn is a generic terminology. In the generic terminology, Sdn is software-defined networking. And software-defined networking means that networking key components like routers and switches are not physical but defined in software. So the software-defined networking allows you to work in OpenShift. It separates between a control plane and a data plane. Where control plane is for network controlling traffic, and the data plane is just to send the packets between the pods that are running in the environment. OpenShift Sdn solves 5 requirements. And the requirements are that it manages network traffic and resources, such as software, such that they can be programmed by the application owners. It takes care of communication between containers that are running within the same project. For your information, if I'm talking about a project, then basically we are talking about namespaces. It is doing communication between pods within and beyond project boundaries. It manages network communication from pod to service, and it manages network communication from external network to service as well. And the network itself is managed by the Openshift cluster network operator. If you are familiar with the Kubernetes networking model, the Kubernetes networking model is using plugins, and something similar like that is happening in the Openshift environment. Good, then there is the DNS operator. Hopefully you are aware that OpenShift is using operators, and operators are automated functions. They are part of the configuration that are automating specific functionality, and DNS is implemented by an operator. Many other things in OpenShift are implemented by an operator as well. And the DNS server in OpenShift is core DNS. And I think at this point I should just be showing you stuff. So let me get access to stuff. I just need a few seconds before I can do that. I am not working on a clean installation today. I'm working on a used installation, and you should be seeing the name of my well, it's not really a name. You should be seeing a terminal session, which is an SSH session from my MacBook to my Fedora machine. On the Fedora machine, I am running CRC. When we chatted before you came into class, I was telling you CRC is really what I expect you to be running as well. So I hope everybody has successfully installed a CRC instance also. When I'm using CRC status, then you can see it's not the fastest implementation. I'm running on a dedicated laptop, but the CPU is a little bit slow. But ultimately, hopefully, it should get there. But hey, this is CRC, and CRC, well, can be surprising every now and then. But there you go. We can see that CRC is giving a status of running. And that means that we can have a look at the configuration. OC who am I is always a good start. I am kube admin. I did not create any users here. So I'm just working as the kube admin user. Robert, you are asking me to move the terminal to the left. If I do that, Robert, it drops off my screen. It is all the way to the left corner of where I am at right now. I will give you a couple of alternative locations. This is alternative location number 1, all the way to the middle. I would like to have your opinion, and please tell me what works best for you. Okay, you want it to be to the other left. You got it, Robert. There you go. Okay, OC Who Am I is showing that I'm kube admin. I did not set up any users in this system, so I just have kube admin and the default developer user that is created when you install CRC. The command that I would like to run right now is oc get co. I like that command. Co is for the cluster operators. And when we do an OC get CO, then we can see the operators that are currently running. In the list of operators, as you can see, there's a DNS operator, and this DNS operator is what we are doing busy with. Now, you can get more details about it using OC describe DNS.operator/default. And that's giving some more insight into what this operator is doing. There you go. We can see status information with the cluster IP and everything else that you need to know about the DNS operator. Now, DNS in OpenShift is pretty important because it makes sure that you can resolve the names of the resources that you are using in your OpenShift environment. Oh, Paolo, you think you still don't see the left part of the terminal. Okay, let me check. Is this better, folks? Please let me know. Can you see it right now? You should see OpenShift at hostname. Can you please let me know if this is better or not? Everybody, I need something in the chat. Robert says it's good, then we're right. Good, thanks for your feedback. Let me continue. And I will hop up and down between the slides. So let me get back to the slides. You should see the slides again at this point. Slide deck number 7. There we go. That's about the DNS operator. So the DNS operator has a couple of roles. It creates the default cluster DNS name, which is cluster.local. It assigns DNS names to namespaces, it assigns DNS names to services, and it assigns DNS names to pods. So the idea is that when you are going to work with OpenShift, DNS knows about all stuff that is going on. And when you create new services, pods, or namespaces, DNS is taking care of that. So DNS is a pretty important component. Also because DNS is what makes your service reachable. Now there is one thing, now that we are talking about DNS. DNS is typically running as a service on cluster IP. And when it is running as a service on cluster IP, that means that it is an internal thing in order to expose the DNS records to the outside world. Another pretty important component of everything is the load balancer. Because in the end your users want to have connection to your DNS, and your users typically come in through the load balancer, and this load balancer should forward the traffic to the appropriate node name. We'll talk about that in a little bit as well, but I just want you to realize that if you just set DNS all by itself, you're not going to get very far. Right, managing DNS records for services, how does that work? Well, DNS names are composed as service name dot project name dot cluster DNS name, and as a result you will see names like db.myproject.cluster.local. And apart from the A resource records, which take care of resolving names into IP addresses, Core DNS also implements a service record, an SRV record, in which port name and protocol are pretended to service a record name. And if a service has no IP address, DNS records are created for the IP address of the pods, and round robin is applied. That's the exception situation. Now, there is a cluster network operator. Cluster network operator is a fundamental part of the networking as well. And the cluster network operator defines how the network is shaped and provides information about network address and network mode and network provider and IP address pools. And that is definitely also something that is worth investigating. Right, I'm going back to my terminal. What happened to my terminal? I can see different terminals, not the one that I'm looking for. Terminal. There we go. No, this is not the one I'm looking for. The funny fact is that you are probably already seeing the terminal. Now I see my terminal as well. So back in the terminal, I'd like to show you OC get network /cluster -o YAML pipeless, so that we can see what is in this cluster resource. So in this cluster resource, we can see the spec, and the spec has the cluster network. It defines the service network, and we can see the status of the cluster network. And we can also see the network type that is used. Network type, that is something that is set up automatically, of course, if you are using CRC. If you are setting up Openshift manually, then this network type is something that you can bring in yourself using the install config.yaml. Hey, can you give me a quick yes or no, just so that I have impression if you have already installed Openshift manually? I do appreciate your yes or no in the chat, please. Because if everybody is saying me no, then I should probably not be assuming that you have done it. And good to see that some of you at least have tried doing that. Yeah, I mean installing a real cluster, the install config.yaml and all the configuration that comes with it. Okay, let me continue. I am back on the slide now. So you should notice that currently OpenShift only supports Openshift Sdn. In the future, they will use OVN Kubernetes to manage the cluster network. So that is not something that is really very important at an EX280 level. If once you would like to prepare for EX380, then we need to talk about it again, but let's not do that now. Right, then there is this thing called network policy. And did I hear a bell? I heard my front door. I'll be back in 5 minutes, everybody. All right, everybody, I am back. Let's continue. Dinakaran, you should have the course materials in the materials section. Can you confirm that you can see it there? Because if you can't, then I have done something wrong and I should have a look at it. So everybody, yes?
Sorry, Sandor. Actually, I couldn't see your materials
You cannot
section.
Okay,
Yeah.
I will double check it right now. You do see course materials part somewhere in the interface or not? Anyway, I'm uploading the course materials again. I don't know what has gone wrong, but apparently first time that did not work out well. And that should bring you a course materials section somewhere in your interface. I'm in a different interface, so I can't really see what you see. But once it is uploaded, still working, then you should be good. And what you will be looking for is lesson 7 and a lesson 8 PDF file. I'm just going to keep that open in the background, and I will slowly move forward so that we don't waste time waiting for an upload to happen. Next component that we should talk about is networking policy. So networking policy allows for defining ingress and egress filtering. By default, no networking policy exists, then all traffic is allowed. And if a networking policy exists, it will block all traffic with the exception of allowed ingress and egress. We will talk about that. The next thing is a thing that I'm going to skip. It's about services. These are Kubernetes services. And I don't have any demo here. I promised in the title of this course that it would be a lab-oriented course. So I would like to focus on the things where we are going to do labs. The labs in this lesson are very much related to routes and network policy. So that is what we should be looking for. I can see that my upload has finished, but it has finished with an error. So can you please check again and let me know if you can find course materials?
Sandor, I do not see anywhere on this interface where there's an option to get course material. It's not the same as the O'Reilly interface.
Okay, then I'm going for a different approach, and I will need 2 minutes. I'm just going to log in as a participant myself so that I can see where we are. Still working on accessing this stuff. I'm almost in as an attendee. And I need to download the application. And it is starting. All right. I can see what you mean. Okay. At least it's good to know that I can see the interface I'm looking for either. As this is labs, I do consider it important for you to have access to the course materials as well.
We're not so many people. Would it help if we paste our email addresses?
Yes, let's do that. It's probably faster. Please put your email address in the chat, and I will just compose an email message. Reading out the email addresses that I just copied. If you don't see yours, please let me know. I have Andri, I have Rob Swalbe, Swolf, I have Robert Charles, I have Motion, I have Paolo, and I have Santos. Do I miss anybody? I will take that as a no.
I think you missed my name, Sundar. Dinakaran, this is.
Can you please copy to the chat?
Yes.
I'm waiting for you, Dinakaran, then I can send over the email. So if you could please post your email.
Yeah, I just sent my mail ID to you.
Dinakaran, could you please post now? We are waiting for you.
Yeah, Sundar, I already sent to you my mail ID.
You don't want to paste it in the chat?
Yeah, I can do it if you want.
Yeah, that makes it a lot easier.
Okay. Yes, sorry, 1 second.
Thank you.
Welcome.
And everybody, there you go. Slides are coming your way. And with that, I will get back. You can still see the slides, and yay, I can now confirm that you can see the slides. So we are going to explore routes now. Our first two labs are about routes, but these labs are only meaningful if we understand what it's about. So what is this about? Well, this is about ingress, really. When we talk about ingress, ingress is a resource in Kubernetes, but ingress is also generic terminology for incoming traffic. And the ingress resource is managed by the Dns Operator, and it accepts external requests that will be proxied. The route resource is an Openshift resource. It provides more features than ingress. And in particular, the route resource provides more flexibility when working with TLS. Historically, Openshift did have a route resource before Kubernetes ingress resource, and I do see some stuff merging here, but I also do see that they're still not the same. So I don't expect anything drastic to happen here in the future. Now, Openshift route resources are implemented by the shared router service that runs as a pod in the cluster. So routes run as a pod. Like many of these parts of Openshift, you will find many of them as a pod that is implemented by an operator. So router pods bind to public facing IP addresses on the nodes, and DNS wildcard is required for this to work. And routers can be implemented as secure and as insecure routes. Now, if you want to create routes, then there are a couple of requirements. And that is in your router resource. You need a couple of values. So that is a name of the service, because in the end, the route resource connects to a service. You need a hostname for the route that is related to the cluster DNS wildcard domain. You need an optional path for path-based routes. You need a target port, which is where the application will listen. You need an encryption strategy, and you need optional labels as well. And also you should notice that the route does not use the service directly. It just needs it to find out to which pods it should connect. So the route sits on top of the service, but the main thing that the route is doing, it's getting information about the endpoint pods that the service is configured to be servicing. Now, when you are going to work with routes, there is a couple of options. So you can use secure routes. Secure routes is definitely the most common way because you are using certificates for TLS-based termination. There are three configurations for secure routes. To start with Edge. Edge means that certificates are terminated at the route. So TLS certificates must be configured in the route. There is pass-through, in which termination is happening at the pod, and that means that the pods are responsible for serving the certificates, and you should use that to support mutual authentication between the client and the pod. And there is re-encryption, where TLS traffic is terminated at the route and new encrypted traffic is established with the pods. And apart from that, there is the unsecure route, and in the unsecure route, there is no key or certificate that is required. Now, how do we create insecure routes? Well, that is relatively easy. You just use the oz expose service command. So you probably already know kubectl expose. kubectl expose is exposing applications in Kubernetes and creates services. If you use oz expose on a service, then you will get a route. And you can select to use the -- hostname option. If you do so, then you will set that hostname for the route. If no name is specified, then as the name, you will get a router name, .project name, .default domain as the name. And that's not always very common. And you should notice that only the Openshift route and not the core DNS server knows about route names. This is pretty important. Core DNS only has a wildcard domain name, and that wildcard domain name sends traffic to the IP address that runs the router software, and that will further take care of specific name resolving. And therefore, the route name must always be a subdomain of the cluster wildcard domain. If you are setting up everything yourself, including DNS, then configuring wildcard DNS really is an important part. Now, before we move on, it also helps to understand Openshift DNS name resolving. Because if you don't, then you risk getting in a lab environment that is never going to work in a decent way. So what is involved? Well, what is involved is that services are the first level to expose applications. You know that, hopefully, from your Kubernetes background. You have your application running in pods, either or not managed by a deployment. You want to access them, you create a service. And to make services accessible, routes provide DNS names. So the DNS name sits on top of the service, and it's a resolvable DNS name. Now, Openshift has an internal DNS server, and this internal DNS server is reachable from the cluster only. And to make Openshift services accessible by name on the outside, wildcard DNS is needed on the external DNS. So whatever at your Openshift domain must be sent to your Openshift cluster for further name resolution. So wildcard DNS in this resolves to all resources created within the domain, and external DNS has wildcard DNS to the Openshift load balancer. That's a typo to the load Openshift load balancer. Let me fix that. There we go. So the Openshift load balancer provides a front end to the control nodes, and the control nodes run the ingress controller and are a part of the cluster. So they have access to the internal resource records. Now what you can see right here is the drawing that summarizes everything. Those of you who know me from the O'Reilly courses probably know that in O'Reilly I draw for myself, but to tell you a secret, when I draw for myself I always have nice examples like this, and as this is material in development, I want to talk you through what we see right here. So in the lower left corner, we see the happy user, and the happy user wants to reach out to blah.apps.example.com. That's step 1. That is being serviced by the external DNS. So for the external user, there must be an option to resolve blah.apps.example.com. And that is the external DNS, which is using a wildcard domain. And this wildcard domain is resolving to the load balancer. So that's the third step in everything. The load balancer, that is load balancing between the different control nodes that you are using in your cluster. So these control nodes, they're just duplicate from the perspective of high availability. In the control nodes, there is ingress and route as well as core DNS. So this whatever.apps.example.com can perfectly be interpreted by the internally running route. The internally running route may or may not need core DNS to fix, to find out what exactly to use, and in the end the traffic can be forwarded to the end user pods. Now I can tell you, and Motion probably knows about that from my previous run. I can tell you that the first time I was running this class, I completely overlooked the load balancer, and if you do, then it's not going to work. So this is really something to consider. Normally the load balancer is an external part of the entire setup, but if it's not there, and that's especially going to bug you if you have your own lab, then it's not going to work. So if I may advise, if you really want to become an expert in Openshift, make sure that you understand load balancing. HA proxy as a load balancer is common enough, and if you know how to work with HA proxy, that should do. Right, next part is about self-signed certificates. I'm going to, well, let me check if I'm going to do that right here. Just need to check. Yeah, I'm going to do that anyway right here. I'm going to talk you through the procedure of creating self-signed certificates. Just for your information, I will have a demo. In that demo, I'm using OpenSSL commands. The OpenSSL commands might not be the easiest way to generate certificates, but still, I consider that it's a useful way because it exposes the full procedure and allows you to understand how to work with certificates. But first, before the demo, one slide about understanding certificates in an OpenShift environment. No, not only in an OpenShift environment, in any environment. So what do we have? Well, PKI certificates are key in OpenShift. And to secure resources like routes, it's essential to understand how certificates are working. And to use public keys, certificates need to be signed by a certificate authority. Self-signed certificates are an easy way to get started with your own certificates. And next, these certificates can be used in OpenShift resources like routes. So how does it work? Well, generically, in PKI certificates, there's a public key, there's a private key. If you are going to connect to external services and you expose your public key to the external service needs to know that your public key is trustworthy. And to make sure that your public key is trustworthy, the key typically is signed by a certificate authority. Certificate authorities can be well-known certificate authorities, and that is what you definitely need if you are going to use them on the internet. If it's for your own use, then you can use self-signed certificates as well. In an OpenShift environment, there is nothing really wrong with self-signed certificates because these certificates are typically being used in internal environments. And what I want to show you now is my demo how to create self-signed certificates. So I'm getting back to my demo interface and I will walk you through it. Obviously, you can find the demo in the slides as well, so it's easy to follow along. So let me get back to my demo interface. Demo interface, where are you? It's here. And there we go. And you can see the demo interface right now. Okay. At the end of this course, I can send you a pastebin. That's a very convenient way of sharing code so that you have access to my entire history. Many people like that. I will use an Echo EX280 labs starts here so that I later know where to start my pastebin from. All right, what are we going to do? Well, I am going to create a directory EX280 pre2 because that is what we are today. And in this EX280 pre2, I'm going to create an OpenSSL directory. And in the OpenSSL directory, I need to change directory to that. I'm going to use the OpenSSL command genrsa. Genrsa is where it all starts. Minus -3, which is triple dash algorithm, minus alt out, I mean my ca.key. 2048 bits, which is not really secure, but I don't need it to be secure, I need it to be fast. So this is what is creating a key for the certificate authority. And I am going to enter the very secure passphrase for the myca dot key. The certificate authority key, private key, that's what we are generating here, is something that is supposed to be extremely secret, and because it's extremely secret, you must set a passphrase. Next, I'm using OpenSSL rec for a request. Minus X509 minus new minus nodes minus key myca.key. So we are going to work with myca.key. Minus SHA-256 minus days 3650 minus out myca.pem. The PEM is the certificate that we are going to generate. And if you are generating a certificate, that's the certificate authority certificate. Typically, lots of external users depend on that. And for that reason, you want it to be valid for a long time. And that is why you can see the days set to 3640. Okay, that was a typo. I wanted to do 50, but that doesn't really matter. As this is something that is supposed to be highly trustworthy, I need to be very careful, and I need to enter my very secure passphrase. Then it is going to prompt for a lot of information. You can enter that information on a command line as well. I don't like that because the command line is long enough as it is. I'm just pressing enter on everything, but not on common name. The common name is the name that is typically servicing this certificate authority. So my certificate authority is hoven.example.com. Bonus points for anyone who can tell me what it is. Email address, that's not really important, but this common name, that is important, because in the end your users are going to connect to something, and if they are going to connect to something, they will receive a certificate, and the certificate has this common name, and the common name is a means for the user to verify that the certificate is indeed all right and is what was expected here. So this is the public key of the certificate authority. Now I can use OpenSSL gen RSA minus out example.com.key 2048, which is generating another key. This time it's a private key. We are not going to generate it as a certificate authority. I just want to extract a public key from the private key and make sure this public key is signed, and that's what we do using OpenSSL rec minus new minus key example.com.key minus out example.com.csr. The CSR is a certificate signing request. This is what you are going to send to your certificate authority to make sure that it can be used. So what do we get? Well, we get again the common name, and this common name is very important when you are going to use it on a service. So myapp.example.com or whatever DNS name you are going to use in the service that is going to use this key. Oops, I said service. I meant route, of course, because we are still talking about prereqs for routes. It's asking for a challenge password. I don't want to do that. I'm just pressing enter on everything that's making my stuff more complicated. So at this point, what do I have? Well, I do have my example.com.key, which is the public key. I do have the example.com.csr, which is a certificate signing request. If you have a CSR, the CSR needs to be processed by somebody, and that's what we are going to do in the last step. OpenSSL X509 minus rec for another request -in example.com.csr -ca myca.pem. The -ca is telling the OpenSSL command which certificate authority we are going to use to sign this thing. -ca key myca.key. In order to do signing, we need access to the certificate authority key as well. So that is normally very much secured. Then -ca create serial followed by -out example.com.crt -days 1650 and -sha 256. So there it is asking for the passphrase because we need to make sure that we are legit, and the result is that we now have a certificate, example.com certificate, and we have an example.com key as well. Just in case you are wondering, hey Sander, why are you including this in a course about Openshift? Well, I'm including this in a course about Openshift because in Openshift, TLS certificates are very important to make sure that you have secured connections. Without TLS certificate, there is no security and things can dramatically go wrong. And that's the reason why this stuff is here. Okay. Now that we know about the TLS certificates, we can move forward and we can talk about the edge route. So 7.7 we are securing edge and re-encrypt routes using TLS certificates. What you are going to see here is what will be a drawing in the final course. What you need to understand is that there are 3 different route types. There's the edge route, there's a pass-through route, there's a re-encrypt route. If you have the edge route, then TLS termination is happening on the router. So you need to make sure that the router knows which TLS certificate, which TLS key to use. The V in the arrow between client and edge means that we have encryption there. The X in the arrow between edge and container means that this is unencrypted traffic. Then we have pass-through. In pass-through, we have the client talking to the pass-through route, talking to the container. And the container is using the TLS certificate as well as the TLS key. And the nice solution that Openshift is using to make sure that we have end-to-end encryption here is that both are configured to use the same key pair by mounting this key pair from a secret. And when I say secret here, then I mean the Kubernetes API resource secret that is very much like a config map. So the resource that you can use to pass secured data to your end user. The third one is the re-encrypt. If you have re-encrypt, then your client is having an encrypted session with the router, and the router is going to re-encrypt to make sure that it has an encrypted session with the container as well. In re-encrypt, you will have a different certificate pair. Now, what we need to know about, in particular also for your EX280 exam, is edge route as well as pass-through. Edge route is relatively easy. Pass-through is a bit more complicated. I want to do edge route, then we do a break, and after the break we continue with the other stuff. So let's talk edge route first. So what is there to know about edge routes? Well, edge routes hold the TLS key materials so that TLS termination can happen at the router. And connections between router and application are not encrypted, so no TLS configuration is needed at the application. And re-encryption routes offer a variation on edge termination. And in that case, the router terminates TLS with a certificate and re-encrypts its connection to the endpoint, typically with a different certificate. Again, we are not going to do re-encrypt here, but we are going to use edge. So what are we going to do here? Well, of course, we are going to debug the typos, and we are going to have access to the Git repo. I'm not sure if the Git repo is up to date. We will find out soon enough. So git clone on https://github.com/Sander van Vugt/EX280. Is that what I want? Yes, that is what I want. It happens to be that this is one of the last demos that I added. So if I have Lingenex V1.conf, then I should be pretty good. And I do, and I also have Lingenex V1. So I think we are good. Let me have a look at these files. First, Lingenex V1.conf. This is an example configuration file for an Nginx service. And this example configuration file is because the Nginx service must service something. In an Openshift environment, you must realize that the services that you are using are typically running as non-root, and if you want them to run as non-root, they can't bind to a privileged port. So that is why we see this listen 8080. And I am going to put this in a config map so that we can use this config map to provide this configuration file within the service. Based on our little chat before I allowed you to get into class, I'm assuming that you know what config map is all about. So I'm not going to explain that here. I'm just going to run oc create cm lingenex 1 -- from file lingenex 1.conf. And that is creating the config map resource for me. Because I'm on my development environment, I might get a couple of error messages about resources that already exist. We'll see. I'll fix it then. I did not want to clean up everything because I'm never sure if I really saved everything the right way. Let's have a look at Lingenex V1.yaml. What do we see in here? We see the definition of an Nginx based deployment. So deployment name is Lingenex. It is using a selector, one replica. The replica is not really interesting here. It is using the Docker container image. And in the Docker container image, it is using the name Lingenex 1 and the port container port 8080. This is not interesting. This is interesting. The volume mount, we can see that it mounts config map volume on the mount pad etc nginx conf.d. So this is what is making sure that once we are there, we have access to the appropriate volume. Then we can see that there's a volumes definition. The volumes definition is fetching the configuration from this default.conf. And we can also see it is using a service account. So I need to make sure that the service account exists. The service account probably already exists. So let's check that in a little bit before we are running this. Let's also check what is in this service. So we can see there's a service. This is the Kubernetes service that is exposing access to the actual deployment. The service is going to expose on port 8080 and it connects to the Lingenex 1 deployment on port 8080 as well. Okay, now I am aware that in this demo we have one pre-requirement that I have not yet documented in the demo, but let me use oc get sa -a so that at least we can verify that the service account is available. Ew, that's a lot of service accounts. It really is a lot of service accounts. Pipe grab Linge. And there we go, we have a Lingenex service account. This Lingenex service account is connected to RBAC to make sure that the service account has sufficient permissions to run the pod. The problem with workloads in OpenShift is that OpenShift expects it to be non-root, and many images by default are configured to run in a root way. So we need a service account, and the service account is setting up the container image in a way that it can run without having these root privileges. I will dig up the service account configuration in a little bit. I will do that after the break, because I am fully aware that without the service account, you can't get this to run. But instead of doing that now, I rather focus on what we are doing here, the flow of creating the deployment, which is getting its configuration from a config map, then exposing the deployment with the service, then creating a route, and then testing the route, because we are almost there already. OC-get pods is telling me that we have Nginx. Nginx, that is not what I'm expecting. So I do need, I need to run the deployment as well. So OC create -f Lingenex V1 Yaml is creating the deployment Lingenex 1 and the service Lingenex 1. Now I can do an OC create pods and prods. That's an OC get, sorry. An OC get pods, and OC get pods is telling me that apparently it's not running yet, but maybe I'm just too fast. OC get deploy. No, let's do an OC describe. Deploy on, what was the name again? Lingenex 1. And there we can see with an age of 32 seconds, it's scaled up replica set whatever, but we have a replica failure failed to create. Are you really going to tell me that my first demo is going to fail again? I'm not sure I like that. Just reading what is going on. It's failing on the replica. Well, if it's failing on the replica, I need to figure out what is happening. OC get RS, where we can see that we do have a Lingenex replica set. So OC describe RS Lingenex. Yeah, Andre, I'm probably missing that configuration. Let me just type it, because that's actually the part that I wanted to do afterwards. But hey, OCADM policy add SCC to user any UID -z. Hang on. Because I need my pod to be there. And I am convinced, Andre, that what you mentioned is part of the solution, but probably not yet at this point. So I do want my OC describe RS on, yeah, exactly, OC get RS. Let's get back to business, and then we are going to do an OC describe RS. I want to figure out what is happening at a replica set level, and there we can see we can see that it has a service account Lingenex SA not found. That's pretty clear, right? So we do need to focus on the service account. I am going to to keep you hanging here because I do like my breaks every hour. I go get myself a fresh coffee, and after the coffee, we will jump out a little bit for the service account demo. I will make sure you get the slides that contain the service account demo as well, and I am going to show you how to run service accounts. I hope that the problem that I'm facing here is dependencies between exercises. This is lesson 7 and lesson 8 about out of a course that contains other lessons as well, and that does contain a lot of information about users and RBAC and stuff like that. So I suggest we have a break. After the break, we continue. We talk about service accounts. After the service accounts, we wrap up the edge router, and after the edge router, we come and attack the pass-through router. Right. Thank you very much. I'm glad you like it, Anneli. I like my breaks to be 12 minutes, so I'm going to start my break timer right now. And I go on mute so that I can quietly get myself organized with some coffee and continue in 12 minutes. So I'll see you in 12. Going on mute right now. Everybody, break is over. Let me enter break timer. There we go. And I have sent you a new set of slides. You should find the slides in your email. And what I'm going to do in the slides is what you can see on top of the slide deck right now. The thing is, we need to talk about service accounts. So a service account is an internal Openshift account that is used for running services. By default, all services are running with the default account, and this default account is kind of limited. And that is why I'm using another service account in this demo about the edge route. The edge router wants to run a pod that needs more privileges, that is not allowed by the current configuration, and that is why we need this service account. And what I want to show you right now is how we are going to create this service account and make sure that the service account has some additional permissions. And I'm just going to run through the demo. The only thing that I'm going to do differently here is I'm going to call my service account Lingenex instead of Nginx SA, and then we should get a bit further. I'm getting back to my demo environment. There we go. And you should be able to see the demo environment. I just need to reorganize that I still have access to my service account demo as well. That's the unfortunate thing of these demos. They are sometimes a little bit complicated. So, but I've got it. Right, what are we going to do? I'm running you through the demo as it is on slide 27 of lesson 6. And I'm just skipping the part about the new project SCCS. I am going to run oc new app --name SCC Nginx -- docker image Nginx. So there we can see it's creating resources. And it is done. OC status can show you that it is done. And if you don't like OC status, to be honest, I don't like OC status too much. OC get all should also show you what it is, what it's all about. Now, what do we see? We see that there is a pod, and the name of the pod is SCC Nginx, and this SCC Nginx is in crash loopback off. So that's not good. So if you have a look at OC logs pod, and I should do my OC completion in a bit I know.
You don't have to say pod.
Sorry?
You don't have to say pod. It's just, oh, you can do that.
Yeah, I know.
If you're in the project, and you can.
Yeah, I agree. So what we see here is that I'm getting a permission denied, and here we can see some stuff about super user privileges, and it's not happy at all. Now, if I'm kube admin, so I need OC who am I to figure out I am kube admin, then I can do stuff like OC get pod, followed by the name of the pod, followed by -o YAML, followed by a pipe, and OC ADM policy SCC subject review -f hyphen. And why is that giving me an error? It's telling me there's no need to specify resource type as separate argument when passing arguments in blah, blah, blah. Oh, I can see I have a backslash before the name of my pod. This is what I was looking for. This is the part where we can see the any UID. So it is allowed by any UID, which means that this pod can run if it is using the SCC any UID. SCC is a security context constraint. That is like a permission, and I need to make sure that that permission is granted the appropriate way. So in order to do that, I need my service account. So OC create as a Lingenex. And there we can see that the service account is created, and I can use OC ADM policy add SCC to user any UID -z Lingenex. So now we have added this authorization for the specific service account Lingenex, and that should be doing so much better. So at this point we can use OC set service account on deployment SCC Nginx Lingenex. And that is going to update the service account to the running environment. And if we are going to use OC, not OX, but OC get pods, then we can see that since 12 seconds we have successfully running SCC Nginx. And that is because if we use OC get pods SCC, and yes, I will take care of that completion. I'm always trying to avoid sidetracks when I'm in a demo. So OC get pods, pod name -o YAML, pipe grab Irvis. There we can see that it's using the service account Lingenex, service account name Lingenex. So at this point we do have a fully functional service account with the name Lingenex. And that is what we were missing in this demo. OC completion -8. And there we go. No, not the ZS8. I need this guy. Right. So this is about service account, and now we can get back to the edge networking configuration. In order to do that, I am going to show you first slides, so that in slides we can see where exactly we were and what was going wrong. So I created a config map. I created this YAML-based configuration, and in this YAML-based configuration, step 2, the OC create -f Lingenex 1.yaml, we got stuck because of the service account. Right, so I want to pick it up from here, and this time make sure that it is going to work. So back to the demo environment. Here is the demo environment again. And in the demo environment, we are going to do an OC get all first. I want a quick overview of where we are and see what is going on. So what do we see? We see we have some pods, the SEC Nginx, the B Nginx. The Lingenex is not very successful so far. So let's clean it up. OC delete -F on Lingenex V1.yaml. And let's have a look at this Lingenex V1.yaml once more. So there we go. Oops, service account is Lingenex SA in this configuration. So that is something that we can easily change. There we go. And now I can use my OC create -F on Lingenex V1.yaml again. And then OC get pods. And we can see that the pod this time is in a state of container creating. It's looking so much better. And now it is in a state of running. Good. So OC get SVC. Now we can continue, and now we can have a look at the service resource. So a service resource has been created with the name Lingenex with the type cluster IP. Just for your information, in case you're not sure about the service resources, cluster IP means that the resource is reachable at an internal cluster IP network only, cannot be directly reached from the outside. If we use OC describe on service Lingenex, then we can figure out what it is doing. So we can see that we have this Lingenex resource running in the BLAN namespace with the type cluster IP with the port 8080, the target port 8080. That is the port it's going to use to connect to the endpoint container, and the endpoint container right now is just one endpoint container. You remember that this is one of the nice things about service resources. If you scale up the number of running pods in your environment, you will see additional endpoints and it will start load balancing automatically. So all that is great, but what would even be nicer is if we can convert this into an edge router. So how do we do that? OC create route. If you type OC create route -H, there you can see the different types. So it's showing you edge and pass through and Re-Encrypt. Now let's do an edge. And there you can see all that it is doing in creating the route. So if you want to create the edge router, then OC create route edge Lingenex 1 -- service Lingenex 1 will do that for us. So here the router is created. OC describe routes on Lingenex. Hang on. Hanging? Not good. You see that? My console is hanging. Let me do 2 checks and figure out what is going on here. You cannot see what I'm doing for a check, but that is because that is more efficient. And I have no idea what is going on, but it had a hiccup apparently. It's a little bit busy. It has a lot of memory in buffer cache, so just doing quick analysis. I don't see anything going dramatically wrong here. Let's just ignore and see how far we are getting. So I was doing the tab completion right, and that is where it had a problem. Oh, it's just very slow. But it's trying to do something. I'm just opening a backup session to see what's going on here. Yeah, and what do we see? Well, we see it's an edge router, right? And in this edge router, what do we get? We get the name, which is Lingenex V1, created a minute ago. It has a label. It has a requested host. So the requested host, that is the automatically generated DNS hostname, Lingenex -1-blah.apps-crc.testing. We have the TLS termination, which is set to edge, and it is connecting to the service as well. So we have an edge router. And now I need to check what is going on. So how are we going to do that? Well, we are going to use this Lingenex blah link in order to access it. So that should be doable using curl -svv. Yeah, that's my initials. I like that. https://lingenex-blah. The slide says default, but the default here is just the name of the namespace. And I'm not in the default namespace. I'm in the apps in the blah namespace. apps-crc.testing. And there we can see, oh no, SSL certificate problem, self-signed certificate in the certificate chain. The fact that we get an SSL certificate problem here is proof enough that it is working. Well, we have double proof that it's working because curl is resolving to a host name that definitely doesn't exist anywhere. So this host name corresponds to the host name of the router that I just created, and that is setting it forward, but it's getting stranded on the self-signed certificate in certificate chain. This is one of these situations where we have the expected error, and if you have the expected error, that means that you are good. And that means that you only have to change one little thing, and instead of my initials, we are going to use -s-k. And what do we see in -s-k? Oh, that is an interesting one. We see application is not servicing, and I was expecting Nginx to be in business here. That is one part where I am not sure about. If anyone has any idea what is happening here and why I don't see welcome to Nginx, please let me know. If not,
Do we see this?
yes.
Sorry, number one, am I allowed to interrupt on voice, or shall I just type a message?
If you put your voice at the moment that I'm opening an option for voice, then yes, sure. And opening an option for voice, I don't like being interrupted in the middle of a complex explanation too much. If you think that in my explanation I am missing the point, feel free to interrupt. Because, hey, if you have a point and what I'm telling you is nonsense, then we shouldn't waste our time on that. So, yeah, feel free to interrupt. And I like it.
Okay.
As I told you in the introduction, we are a group of 8. So open your microphone.
Yeah.
Let's keep this, let's make this a workshop and work together. So please.
Okay, great. I think let's have a look when we created that route and exposed that route. Let's have a look at the notes, the selector, the label selector, the service, and whether the right port from the service is exposing and whether that's in the routes selector.
So what do you suggest that I type right now, Andri?
So first of all, let's do a OC get route, or describe the route.
OC describe route. There you
and
go.
then is it Lingenex, yeah? Blah, 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 blah. Okay, cool. Labels, deployment line. Cool. And it's going to on port 8080 for that pod.
Yes.
Okay, so then let's see if that goes to the root goes to a service and the service to a pod, or does the root go directly to the pod?
That is a good question. So we can see the endpoints 10.1.16.0.42, OC get SVC. This is
Okay, cool.
this is a service. OC get
Okay,
pods
pod minus 01.
wide, and there we can see that it is reaching out to the pod. No, 42. Yeah, I was just selecting the wrong line.
Yeah, and the pod has a pod listening on what port? Also 8080.
Yes, that's also on 8080.
For a second.
Are you able to reproduce this, Henry?
I'm trying to do so now.
Okay. Because everybody
Carry
gets
on in the
exactly
meantime.
what I had in mind with this course. I run you through the demo, and hopefully you run the demo as well. You make a slight typo, you see different result, and that is how I hope to get your input in making my stuff better, and at the same time teach you guys something. Henry, if you have anything to say, I'm waiting.
Not yet. Please carry on.
Okay.
I'm still figuring out this side.
Okay. In that case, shall I just continue with the pass-through routes? And at the moment you have something to say, you tell me.
Good.
All right. Okay. Which means that we have half of a successful demo. Well, I'm an optimist. It's at least half of it. Let's have a look at pass-through route. And before doing that, I'll show you the demo, the slides. So here's the slides. First, understanding pass-through routes. So what is pass-through? Well, a pass-through configures the route to reuse the certificates that are used in the application to guarantee client route application end-to-end encryption. And to make that happen, a secret that is providing the certificate as well as the certificate key is created and mounted in the application. The pass-through route doesn't hold any key materials, but transparently represents the key materials that are available in the application, and the route itself doesn't do TLS termination. And pass-through is the only method that supports mutual authentication between application and client. This is a somewhat longer demo, so let's just run it. And before I am going to do it, I'm just reading on what I'm going to do, trying to avoid any conflicts here. And I think we are good. Notice that this is a two-slide demo, by the way. We start by creating certificates. After creating the certificates, we are going to create a secret because the secret is going to expose the certificates to the application. Then we are going to create a config map because the config map is exposing the configuration to the application. Then we will continue with step 4, and in step 4 we are going to start the deployment and the service. And in particular in step 4 we need to check the usage of the deployment as well as the secret. Then we can create the pass-through route, and this pass-through route needs to be created with some port as well as a hostname. Hostname can be dynamically generated, of course, but you can also set it to anything that you would like. So in this case, dash hostname is Lingenex default.apps.crc.testing. Now that I see that, just checking if that is what I want. Yeah. In the certificate, we set the common name to Lingenex default apps crc testing as well. Then we expose our stuff and we are going to test using a debug pod. And this debug pod will show us that this is going to work, hopefully. Right, just a quick double check for myself before we get started. There we have the demo machine. And there we go. And I'm going to do something that I should not do because, hey, yeah, I'm not sure I like you to see how many mistakes I make before doing it the right thing. But hey, at the same time, I'm only human. So history grep pass through. And I just want to verify, yeah, command 577. That is the one that I got working. Good, we are now in 699, but I probably should verify my routes, excuse me, as well as my services, as well as my deployments, and do a little bit of cleanup. OC get routes. Is taking a long part, but I can see one route that is good. And OC get, yeah, that's because I'm in the blah namespace, right? OC gets just one thing that I want to check: API resources. Oh, it's not OC get, it's just OC API resources. Grab route. What I'm looking for is whether or not these things are namespace. I'm just wondering, trying to avoid any conflicts here. And I can see namespace is set to true. That's awesome. Then I don't risk anything. OC projects is showing that I am using test project blah on server whatever, and that is good enough. I think that is all for my sanity checks, and let's just run this demo. Where am I? I'm in the Git repo. I don't want to be in the Git repo. I want to be in the closed SSL directory. Everybody always talking about open SSL. Let's do closed SSL today. And we start with part 1 of the demo. So OpenSSL gen RSA minus -3 minus out myca.key 2048. There we go. Passphrase going once, going twice. Then open SSL rec for request -x509 minus new minus nodes minus key myca.key. I'm just wondering why I'm not using the certificate authority that I created earlier, but I guess the answer is because I don't. Which means no real answer. Minus out myca.pem. There we go. myca.example.com or whatever. Right, then OpenSSL gen RSA minus out tls.key 2048. Followed by OpenSSL request minus new minus key tls.key minus out tls.csr, which is where we create the certificate signing request. Now in the certificate signing request, it is the common name that is most important, and the common name this time is going to be set to Lingenex blah. The slide is mentioning default because that was made in the default project, but I'm in the blah project and I intend to stay there. .apps-crc.testing. There we go. And please shout if I make a mistake with this name later. This is one of these things that's easy to forget. So now we can produce a certificate using OpenSSL X509 -rec -in tls.csr -ca myca.pem -ca key myca.key -ca create serial -out tls.crt -days 1650 SHA-256. Enter passphrase. That is going to be my very secret passphrase, and there we go. ls is showing that all my certificate material is there. Now, and still from the same directory, that is, I can create the secret. Secrets, as you hopefully know, are like config maps. The only thing with the secret is that the contents of a secret is base64 encoded. It's encoded, not encrypted, so they are not that secret, but it's the best thing that we've got if you look at the native application and not at external solutions. So let's use OC create secret TLS, Lingenex search -cert tls.crt-key tls.key. Now, in case you are wondering, hey, how about the names of these certificates? Well, that is something that needs a little bit of attention as well. These names of certificate, they are not random at all. We are creating the secret to be used by an application. The application is running some service, and the service is expecting the secret to be present at a specific location. With a specific name as well. You know, if you have ever configured a secret, then you know that, if you have ever configured TLS certificates and applications to use them, then you know that it is hard-coded in the application configuration. So these names are not random at all, and you need to make sure that you are using the appropriate names. Hence tls.crt and tls.key, which are the default names that an Nginx web server would be looking for. Good. This is the secret. And now if we use OC get secret Lingenex search -o YAML, then we can see the contents. Lingex. You know what? I want the names to be matching. In a 20-step procedure, I don't want too much stuff in my head to keep in mind when I'm moving on. There we go. And we have the data section in the secret, and in the data section we have the base64 content of the TLS CRT, as well as the base64 coded contents of the TLS .key. And that is good enough for now. Now we are going to work on Nginx, an Nginx application. The Nginx application doesn't only need access to the TLS secrets, it also needs access to a configuration file. And that is why we should have a configuration file. Didn't I put in the configuration file? Okay, CP, no, not CP, ls*conf. Do I have anything else that I can use? No, because I'm not in the right directory. That's me talking to myself in case you're wondering what's happening. ls*.conf, there we go. Here's my configuration file. Being in the right directory every now and then helps. So if we do a cat on default.conf, then what do we see? We see an Nginx configuration that is taking care of secrets as well. Now, the thing in this configuration file that we need to consider mostly is that right here we can see SSL certificate pointing to etc Nginx SSL TLS.cert and SSL certificate key pointing to etc Nginx SSL. In particular, we need to keep in mind this etc Nginx SSL directory because when we are going to explore the contents of the deployment YAML. In the contents of the deployment YAML, we should see that the secret is mounted on that location. And because the secret is mounted on that location, let's get back to the secret. Because the secret is mounted on that location, it creates files with the names that are used in the secret as key. So it creates a file tls.cert and a file tls.key with the decoded contents. So the contents is encoded in the secret. It's not encoded once it is in this file again. So what do we need to do now? Well, we need to put this default configuration in the config map. That is decoupling. You know, decoupling, that is a big thing in Kubernetes as well as Openshift environment. You want to keep the site-specific information out and separate it from the generic configuration. Because that's the idea, the generic configuration can be distributed. So I am going to use OC create CM for the config map, Nginx config map, --from file default.conf. And then OC get CM -o YAML. I have one config map only, so I'm too lazy to specify the name. We can see the config map has a data section. Here is a data section. In the data section, we see not in a nicely formatted way, but hey, who cares? We see the contents of the config map. Now, we also need to make sure that we don't get the problem of this service account again. And that is why I included OC create SA Nginx SA. So that we have a service account that can be used later. And OC ADM policy add SEC to user any UID -z Nginx -sa. That is going to set up the appropriate cluster role to the Nginx SA service account. This is really what we've just done in the configuration of the edge router as well. Right, then it is time for part 4 of the demo. And in part 4 of the demo, we will be using Lingenex V2.yaml. So vim on Lingenex v2.yaml, and what do we see? We see a lot of stuff, and we need to figure out the stuff that is interesting. We can see a lot of Lingenex 2, that is the label. By the way, I changed names in this file, so I hope I didn't mess it up while changing names. And I'm not really sure if after verifying that it worked, I verified this file. So hey, we might be in for some nice troubleshooting here. But what I want to look at, we are starting a deployment. The name of the deployment is Lingenex 2. Lingenex 2 is starting a container. The container is docker io/nginx, and the name is Lingenex 2. It is using a port, and the container port is 8080. Here we have a container port 8443. And then we have the volume mounts. So what do we see in the volume mounts? We see a mount path etc Nginx SSL on which we mount TLS certs. And we see a mount path etc Nginx conf.d on which we mount config map -volume. And if we go a little bit further, then what do we see? We see the rest of the relevant configuration. So volumes TLS certs is pointing to the secret that we just created, and the secret that we just created is Lingenex certs. Everybody, please double check with me that all the references are okay, because if this guy is going to fail, then it is going to fail because of one of these references, and you can search for ever for just one stupid typo. You probably know that. Okay, then we have the config map. The config map is Nginx config map. The internal name is config map volume, and this config map volume is right here. So Lingenex search, internal name, TLS search is right here. I think this should be doing all right. And we also have the secret account and the secret account name, which is Lingenex SA. I think that is consistent as well with what we want to do here. Let's also check the service. So in the service, we can see still the label set to Lingenex and the ports that are exposed on the server, 8443 and 8080. And we have the selector that is connecting the service actually to the deployment. So I don't know what you think, but I think I made my file modifications successfully and we should not have any issues here. Okay, before we are, not before we are continuing, just OC create -f Lingenex V1 This is always one of these moments where your command jumps out and you are just wondering, oh, should I check immediately? I always try to give it 10 seconds or so. So OC get pods. That is going to show me that I don't have any pod being in a state of being created. So OC get deploy. Did we overlook anything? This is not the one, right? I just created OC get deploy right here, 0 out of 1. I overlooked something. That is pretty obvious. So what did I overlook? OC get RS. We do have the replica set, and the replica set just can't make the pod successfully. So OC describe RS on the replica set. And what do we see? Oh, we see the service account Lingenex SA is not found. What was the name of the service account? Nginx SA. Aha. So OC create SA Nginx SA. No, we already did that. So OC delete -f. And I know I can use OC set, but OC delete. Yeah, OC, okay, OC set. OC set makes me think a little bit more about what to use. And you are totally right, Andre. If I don't use OC set, I should be ashamed. So, okay, OC set. SA, and the SA is going to be set for the deployment, and the deployment is what was my deployment? This is why I don't like OC set, right? So OC set SA deployment Lingenex 2. And we are going to set to what was the name again of the deployment. I say deployment, but I mean service account. That should be Nginx SA. There we go. Andre is asking which SA is in the deployment versus which created or assigned permissions. Yeah, I'm messing up here. I created an Nginx SA deployment, and that is something that I need to fix in my YAML file because the YAML file is referring to the Lingenex thing, and my Lingenex thing. There we go, Lingenex V2, and where is the service account? You see Lingenex SA. I think the easiest fix, and please allow me to do that right now, is to fix it in the slide. So let me fix that in the slide real fast. There we go. Back to step 4 of the procedure. We have used OCSet, and OCSet should give me pods. So are we in business? We are in business. Lingenex 2 is running. I'm so happy that this was a minor issue. And of course, I only added this issue for a better learning experience. You totally agree with that, and you totally believe that, don't you? Okay, so now it is time to continue with step 5. And step 5 is where we are using OC create route pass through. What is that weird noise? That was probably a nothing. So OC create route pass through. Lingenex service Lingenex 2 port 8443 hostname. Is Lingenex default? No, this is where I had the reminder. So Lingenex blah dot apps dash crc dot testing. And there we go. OC get routes. First, I want to see it short. So I have a route with the name Lingenex. Maybe I need to make these names a little bit more consistent, but hey, who cares? The service it points to is Lingenex 2. It's using port 8443, and the termination is pass through. So that is looking all right, I guess. And OC get SVC, and the service, well, Lingenex 2 is only a way of getting access to the pods. We've just seen how all of that is working. So traffic is going to be addressed to the route, and the route is going to forward the traffic actually to the pod. So how are we going to test that? Well, in order to test it this way, I'm going to use a debug pod. So OC debug -t deployment Lingenex 2 dash image registry.access.redhat.com/ub8/ub:8.0. You probably are aware that UB is the universal base image, and this universal base image represents everything Red Hat. So it's a universal base image that Red Hat is using for anything that is based on RHEL 8. I'm using debug. OC debug is opening a new pod within the same settings of the deployment, and that is what makes it a little bit easier to track all of this. Now, there is one thing that I need to check before doing that. So let me do OC get SVC. And yeah, that is what I needed to check. So now I can run my debug pod. Always takes a little bit of time. It should find the UB8.0 image locally, so that shouldn't be an issue. And we're at the prompt. So curl -s -k https :// IP 172.25.68.70. And what is that giving? Well, that's not giving anything. And then we are going to use curl on https :// lingenex -blah dot apps crc dot testing. And what do we get? Oh no, we get an SSL certificate problem, unable to get local issuer certificate, more information here, curl filled to blah, 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 blah. We get an SSL certificate problem. At least that is telling us that we get an SSL certificate. Now, if you would be in a graphical environment, and that is what I'm going to do in my course. In my course, we are going to be in a graphical environment. Because if you're in a full Firefox environment, you can click the certificate and you can investigate what is going on in the certificate. But I think for now, the error message is kind of good enough. Kind of. If you don't agree, just let me know, because don't forget, everybody, you are here to help me improve this. And if you don't agree, that is awesome. Then I can make my course material better if you tell me how to do this. Curl -- insecure. Henry, I went out of my debug pod. I shouldn't have done that. Where are we? We are here. I am going to use the curl -- insecure, and now I do have to type. Am I going to type everything again? Of course I'm not. We are going to use the mouse. And there we go. Good suggestion, Andri. Easy fix. Curl -- insecure. Welcome to Nginx. I think that I'm going to rewrite my demo to also do a curl -- insecure, so that I can first tell people about the certificates error, and then we can take care of the -- insecure. Andri, good question. Andri is asking, have you imported the certificate into the local machine store? No, I have not. I want this demo to be mostly about routes, not too much about certificates. And yeah, please allow me to just add this to the slide, because I think that is a good addition. Anyone else, any feedback about this lab? To be honest, and in classes like this, I just want to be honest. This was my nightmare lab in development. It was not easy at all. And if you think there is anything that I can do to make it better, easier to understand, please do let me know. Yeah, Andrea, I'm pretty proud of it, to be honest. For the simple reason that this is the lab where everything kind of is coming together, isn't it? It is bringing in deployments, replica sets, service accounts, SECs, pods, secrets, config maps, and routes. What else do you want? I really feel like this is the lab. If you understand this, then you are close to understanding almost everything. Hey, Andri, you were talking about power outage that you are going to experience later. In how much time is that? Because I really like your output. I'm going to miss it if you're no longer here.
It's in 45 minutes, but I'm making a plan to get some wireless 3G, so I hope to hang around.
Okay, nice. Well, if not, then there will be the recording. But yeah, a recording is such a sad alternative to working with people in real life. Everybody else, I'm getting feedback from Andri. Everybody else, are you still here? Are you already completely lost? Can I get some quick feedback? This is the part where I do need to wait for at least a minute or so to see if people are going to give me feedback. at least Robert still here. Dina Karan looks good. All right. and everybody else no feedback. That's a sad reality of online classes. No matter how good the contents of your class is, people start doing multitasking. Boo-hoo, that makes me sad, but that's just the way it is. Folks, I go get myself some fresh coffee, load up for the next part. Next part is about network policies. This has a lab. Did I include it or did I? Yeah, I still have it in there. This has a lab that has a bug. If you feel like debugging, the bug lab is on slide 38. So if you want to do something during the break, if you already know about network policies, feel free to do so. If not, I am going to switch on the timer again and I see you in 12 minutes. Let's do another break. I need coffee refill. See you in a bit. I'm just wondering, I'm going to steal some time from you. I will make this a 9-minute break because my most active guy might not be with us anymore in just a couple of minutes. So 9 minutes, gonna be a quick coffee. I'll leave my audio open so that you can hear me when I'm back, and maybe we start even earlier. So if you want to do a break, just go get some coffee with a maximum of 9 minutes, and then we will continue and do network policy. And again, if you think, hey, Sander, your mic is open, that is intentional, folks. Okay, I am back. Can you just check in, let me know if you're here? Say yes in chat, please. Okay, that's at least half of you. That's good. And Robert is here. The important guy is here. Mr. RHCE. All of you, don't think that this platform is completely anonymous. But Robert and Santos are both with me in Living Open Source. We organized events in Kenya as well as Zambia and even in Malawi, and that's how we know each other. Hard to understand that in these days that there was a day, a time that you could meet people face to face. Good old days. Let's continue. Let's do network policies. And I will end the timer. And Santos, do remind me that we need to talk about Ethiopia and the option of doing online. I've seen your message, just not had the opportunity yet to answer. Right, I would like to talk about network policies. So, what is network policy? Well, network policy is, of course, Andri. Habari yako bwana kimani. Muribwanji. That's about all that I remember. What language is that, Andri?
That's Swahili, which is Kenya, but our friend Robert speaks my favorite language, which is Kikuyu.
Okay, nice. Wow, so you are talented in African language as well. That's cool.
Yeah, man, I love this continent.
Me too, me too. From 2018 until COVID, we have done how many events, Santos? I think we've done 4 in total. And then COVID got struck, and with the kind of people that we are aiming at, I'm just not sure if it makes sense to do anything online, because we are aiming at meeting people and giving people a chance, and the people we want to give a chance sometimes come in without a laptop. Can you imagine when we did Malawi? I think about 40% in Malawi doesn't even have a laptop. How are they ever going to be able to join online, especially with the crazy prices of internet in Malawi? But hey, that's off topic. Makes me dreaming about the good old days. And yes, Santos, Robert, I'm so looking forward to coming back. But now I'm looking forward to talk about network policies, which is also cool. Yeah, by default, there are no restrictions to network traffic in Kubernetes. That is, you can do it differently if you are setting up Kubernetes as well as Openshift. If you set it up, you can organize it in a way that there are isolated networks, but by default, pods can always communicate, even if they are in other namespaces. That's something that not everybody realizes, because folks tell you, hey, you are in namespaces. Yeah, then you are totally secure. Well, no, you are not, because by default, everybody is in the same /16 network address range. So that means that everybody can reach out to everybody, and that's why you need network policies. Network policies need to be, now it's something that we don't need in an OpenShift course. If in a policy there is no match, traffic will be denied. And if no network policy is used, all traffic is allowed. That's a default solution. So you are going to use a policy. This policy is going to use selectors based on labels. And if there is nothing applying to your current resource by these selectors, then it is going to be denied. Now, in a network policy, there are 3 different identifiers that can be used. You can use pods using pod selector, and you can use namespaces using namespace selector, and you can use IP blocks using IP block. And thank you, Robert. And when defining pod or namespace based network policies, selector label is used, and network policies do not conflict, they are additive. Additive in a way that you just get to all of the network policies, and as soon as there is something that applies to you, then you're good. OC label NS -- type. Where do you see that, Andri?
In the lab demo advanced network policies, there is the 3rd command that says OC label NS source project.
Yeah.
-- type. That -- type is not a valid flag or argument.
Yeah, I am looking at providing a label. It should be without the -- isn't it? So type is some access, that is key equals value. So the key is type and some access is the value. Do I have my syntax right if I do it that way, Andri?
The type is not a valid option.
Hang on.
You can label it and then just say what the label is and then pass it.
That's what I want to do here. But what am I missing in order to do that?
1 second, I'm just looking into it.
Yes, thank you. If I have a quick look at OC label -h, I think it should be working. Let's investigate. Let me finish these slides, and we will get there, and then we will see what it's doing. We can easily verify and have everybody follow along when we do it in the demo. Right, last, allow ingress and monitoring. If cluster monitoring or exposed routes are used, ingress from them needs to be included in the network policy. And you are going to do that by using spec.ingress from namespace match labels and define the lines that are here. And that makes sure that it's going to work out all right. Then I have 2 demos. Then demo number 1 is a simple one. So let's continue with the simple one. That one is working. Demo number 2, advanced network policies. That one is not working. We will get on that later. But it certainly will help if we first review what is in demo number 1. So here we go. Demo number 1. I am going to show you the shared screen once more. Oh, I was still in the shared screen. I was. I thought I was in the slides. I did not verify. I'm sorry for that. Let's start with NW policy. Complete example.yaml. So what do we have in this YAML file? We have a network policy. The network policy has the name access Nginx. It has a pod selector, and in the pod selector match labels app Nginx. So this is what it is going to apply to. It's going to look for pods that have the app is Nginx label. App is Nginx is typically what you would get if you create a deployment. Deployments automatically get at app equals name of the app. Then in the policy we have a very simple ingress, and the ingress is from, so we are going to allow access from pod selector, and the pod selector match labels is access is true. So what are we going to do in the rest of this demo? Well, I will show you when we run through it. It's going to be very simple. And we can already see it here. You can see the second part of the YAML code is defining a pod. And in this pod, we first have Nginx with the label app is Nginx, and that makes that this network policy applies to this pod. And then we have a container, and nobody cares about the container. Container is not relevant for what we are doing here. Then we get the busy box, and in busy box we have app is sleepy, and we don't have access is true. So what is that going to mean? Well, that is going to mean that we implement the network policy, and after implementing the network policy, we are going to apply it, and it will match to app is Nginx, so it will match to the Nginx pod. So OC apply -f NWP and WP and W policy. There we go. Let me take care of my coffee while it's still warm. Okay, exceeded quota, black quota requested. Come on, pods is 1, use pods is 5. Really, I don't remember how to clean up these quota. So OC new project help. Let's call it the help project. Yeah, I can also delete some old deployments, but I guess that this will also do it. OC apply -f. There we go. Yeah, and I know, Andri, check resource limits. I absolutely know, but I'm too focused on this right now to switch to that. We'll talk about these resource limits later. And you know, in Openshift, especially this level of Openshift, and that's why I'm doing so many free pre-release courses. Syntax really is something that I need to get used to as well. But hey, this works as well, even if it's not a solution. And gradually, my system will run out of resources. I'm totally aware of that. But that's something to worry about later. What I want to worry about now is OC expose pod Nginx -- port is 80. And then we can use OC exec -IT busybox -wget -spider -timeout is 1 Nginx. The -spider is just trying to fetch a file in instead of no, it's checking if a file exists instead of showing you everything. And here we can see download timed out command terminated with exit code 1. Now, why is that? Well, that might be because there's a network policy in place. And if that is the case, OC label pod busybox access is true. And then we are going to use OC exec -IT busybox blah blah again, and there we can see a remote file exists. So this is a simple network policy, right? In the simple network policy, we have seen that it applies to the source label, and it's filtering access based on the target label. So the target label is this access is true, and that is why it's working. OC get projects, and I probably need to do an OC delete NS quota test. If you try it in Openshift, you risk getting stuck in a quota that is being deleted forever. Did I say Openshift? I wanted to say Kubernetes. Openshift should be able to deal with this properly, hopefully. I'm just starting to worry. Yeah, it's deleted. And let me also delete the namespace blah. I just noticed that the system is getting a little bit sluggish, so I want to clean up a little bit to avoid that we need to do a troubleshooting on running out of resources. And now I'm not going to delete anything anymore. This should have created a little bit more space. I'm going to run the Advanced Network Policies demo. So let's just go through it step by step. And first step is OC who am I? That should be okay. I'm admin. Next step is OC new project, source project. And it's using the source project, so that is okay. Then we get to the OC label NS source project. Type is some access. This type is some access, that is meaningless. Type is just the key and some access is the value. So if we use OC get labels, get NS source project -o YAML, then in the YAML code we should see the label. There we go, type some access. Yeah, the slide was wrong. That is totally right, Andri. And I just fixed it on the slide, but you can't say that. But thank you very much for telling me about it, because Andri, that might just be the reason, you know. And we'll figure out. We need to have a look at Nginx source1.yaml. And what is this doing? Well, this is creating a pod, and the name is Nginx access, and the namespace is source project, and then we have a spec, and that's a container, and the container port is 8080. So let's do an OC create -f. Yes, Andri, didn't I tell you? I'm so sorry for that. https:// github.com/sandervanvugt/EX280. Here you go. I just git cloned from the GitHub repository. En alsjeblieft, Andri, graag gedaan. It's cool. Andri, you are speaking everybody's language here. I'm not sure if everybody is involved, but I think you are getting quite far. Andri, how is your Italian? And how is your, I think, Hindi? Okay, let's continue. Nginx source1.yaml. We just created it. Then we have Nginx source2.yaml. And what do we see here? We have a new pod with the name Nginx no access. I like using silly names like that to make it totally clear what I want to do here. The label of the pod is type no access. The namespace is source project, so still the same project. And then we have a container, and the container is on port 8080. So kubectl create -f nginx source 1.yaml and source 2.yaml and kubectl, look at me, oc get pods. I'm sorry for the kubectl guys, but I've been teaching Kubernetes all week last week, so kubectl is still in my brain, tagged somewhere, labeled somewhere. Okay, oc project target project. So that's a new project. And then I'm going to log in as a new user for the change. So OC login. I don't have Linda, so I'm using -u developer -p password. That is, isn't it? I'm not even sure. But we have history.
Yeah, that's correct.
Sorry?
That's correct.
Okay. No, it's not correct. It's developer. That's why I have history.
I mean -p. -p is correct.
No, I was just wondering about the passwords. So what is this? I am just wondering. I created. What did I do? I think I messed up the steps on my slide. Just assuming that you have the slide in front of you. I have OC project target project. I do that as kube admin. Then I log in as user Linda. Then I do OC new project target project. I think it needs to be swapped around. So let me get back to kube admin. And from there, let me do what? Now I'm confused.
You were supposed to create the target project as another user.
Yes, that is right. Yes. So OC delete ns target project. And then I go back to developer, and then as developer I create my target project. Why doesn't it find target project?
Try delete project, OC delete project.
OC get ns.
Test project.
Test project. That's.
Rather check your history.
I have source project. I have history. And I'm using OC project. I never created the project. Okay, now I'm a little bit confused, but I think I understand.
So now log in as the other user and then do an OC create new project.
Yes. Yeah, that's what I wanted to do. I assumed that I created the project, but I never created the project as the root as a kube admin user. So now I'm in the other user shell, and now I can use my OC new project. Target project. And now using target project, and that seems to be all right. Okay. So now I can do new stuff. And the new stuff I'm going to do now is OC new app, --name Nginx target, --docker image k.io/openshift test/hello -openshift :openshift. This is just one of these hello applications, and sometimes it's nice to have a simple application. So OC get pods -o white, And we are in container creating, but once we are out of container creating, then we should have 2 pods in source project and one pod, this Nginx target, in target project. So what are we going to do? Well, based on the name of the pods, and feel free to open the YAML files for the pods again. Based on the name of the pods, we are going to use these pods to access the pod that I just created. So that's the purpose here. And the purpose of the network policy is that in the network policy we are going to allow one part and we are going to deny the other part. OC get pods -o wide. I'm just thinking that once I'm going to record the final training, I should probably make a drawing at this point so that people can visualize what I'm doing here. So here we can see Nginx target running on IP address 10.116.0.73. And then OC exec, not ox, OC exec -IT, Nginx access, curl to IP of target pod, and IP of target pod that is going to be 10.116.0.73 colon 8080. Namespace and hyphens. So let's start with the hyphens and then let's do -n source project. And then what do we get? Oh yeah, user developer. Okay. Control R cube admin. And then let's try it again. And there we go. Hello, Openshift. Please allow me to do fixes on my slide before I'm continuing. Obviously, I also need to fix the second bullet. And there we go. So this is number 1. Then we can do something similar for Nginx no access. And the thing here is that we need to try to understand if Nginx no access is going to get access, yes or no. What do you think? Are we going to get access, yes or no? Well, we get a hello OpenShift for the simple reason that there is nobody telling us that it shouldn't get access at this point. We don't have any network policy, right? So now we are going to the network policy, and that is going to be NW poll allow specific.yaml. So what do we see? We see that we create a policy with the name allow some, and we have a pod selector, and the pod selector is looking for the match label type incoming. And then we have the ingress, and the ingress is coming from namespace selector type incoming and pod selector match label type access. So what does that mean? And this is where we really need to realize what's going on. This means that this policy is going to apply to any pod that has the label set to type incoming, which is not yet the case for my Nginx target. Just making a mental note to myself. So at the first run, this network policy is not going to apply to the Nginx target, so we should expect no access. then we can see the ingress, and the ingress is set to a from. And this from is a list. And if you have multiple items in the list, so multiple hyphenated items, then it's an OR. If you have one hyphenated item, which includes a namespace selector as well as a pod selector, then it's an AND. So we need to meet both criteria. So what do we have? We have a match label type incoming, which is a namespace selector. And this namespace selector, node to self, does not exist yet because we don't have type incoming on the namespace. We have type some access on the namespace. So let me fix that and let me move that to some access. Then we have the pod label match label type access. And this match label type access, well, that is going to meet the requirements on Nginx source 1 and not the requirements on Nginx source 2. So in the end, once this is operational, and hopefully with this fix, because I think I found the biggest problem here, a mismatch of the match label. Hopefully with this fix, it is going to work out all right, and it is going to apply to allow access from Nginx source 1 from the source project to the pods that are using the match label incoming. Does that make sense?
Yep.
Right. Let me fix it on the slide so that I don't have to also fix my files in the GitHub. Future version will have type is incoming and match label is incoming. Good. kubectl, get out of here. OC create -f nw poll allow specific.yaml. So there we go. OC exec -it Nginx no access -n source project curl. Oh, what was this IP address again? That is 10.1.16. Well, let me just do it this way. Copy and paste. So do I have it here? I do, and I'm getting hello OpenShift from no access. That's not what we intended to do. But why is that? Well, that is because we want to run a network policy, but this network policy does not apply to the pod. So OC get pods. Why is this thing so slow? And OC label pod Nginx target whatever type is incoming, and I don't need it to be in target product because it's already in target product. So there we go, and then we do our no access as well, and this is the moment. Ooh, is it going to work? That looks like it is not going to work, which is exactly desired behavior, because that's what you want to accomplish with the network policy, right? But given the fact that this configuration is not very fast today, I am going to leave it the time that I can fix my slides. So what did I say? No -n target, and this is just me talking to myself. -n source project and -n source project -- curl and so on. I think we are safe to give this a Control-C. This is taking quite a long time. And now we need positive proof, so it looks as if we are going to be successful, but we only have proof, and yay, we have proof. We can see that the exec minus IT Nginx has access, and Nginx no access has no access. So that means that my last failing lab, as far as I was aware, is working as well. Any questions? Or feedback or whatsoever? Well, Andri, I can tell you, I have courses where I have thrown together all slide materials in 1 or 2 days. I've never spent so much time on developing the materials since I was learning novel netware clustering back in 1996 or something like that. But that makes it all worth the effort. And that makes it worth the effort so much that it's even fun providing training for free. Oh, netware. Andri, you used to be a CNE as well. Nice. Andri, by the way, have you ever heard of Open Horizons? Talking about netware, groupwise, Open Horizons. The reason I'm asking is that Open Horizons was very much novel-oriented user community, and we did events in many countries. And I have been in South Africa as well, in Cape Town and in Joburg to teach at Open Horizons event. Given that you seem to have done something with netware. We might even have met if that is something you've been involved in. Have you or have you not, Andri? Just wondering.
That was in 1998, so I can't particularly say. I've done a bit. I'm old.
Okay. Yeah, when I was in South Africa, that was when Adjafjala Jokul brought down all air traffic in the western part of the hemisphere. So that was a bit later.
Yeah, it's possible.
Yeah. All right. Folks, I am happy with these labs. I am going to skip 710. 710 is not so interesting. I would like to leave lesson 7 for what it is, and I would like to have a look at lesson 8, which is different business. Let me bring up lesson 8. First, I need slides. There we go. Controlling pod placement. Then I need to share stuff. Lesson 8, here we go. I want to talk you through some of the basics before. What we are going to do in this lesson, we are going to do node selector. Node selector, which allows you to run pods on specific nodes. Then we are going to talk about manually scaling pods, and probably just talk because that's boring. Next, we are going to discuss the HPA, the horizontal pod autoscaler. And next, and that is definitely the more challenging part here, is pod resource limitations. Now that I say that, we still have 2 hours remaining and I don't have time to go overtime. So I do know where the challenges are. The challenges start with the pod resource limitations, because we have resources, we have limits, we have templates, and that is something that might be a little bit confusing. I don't want to start with the easy stuff. I want to start with the difficult stuff. And who knows, after doing resource limitations, applying quota, limit range, and specifying quota range, and modifying the default template. After doing all of that, if you still have time left, then we do these other things, node selector and stuff like that. So we will be jumping in at applying pod resource limitations. Let me also put the slides on the right position in my other computer. I did not have it open yet. Slide 17. Here we go. So let's try to understand what this is about. This is about pod resource limitation. That's in fact how Openshift is interacting with C groups in the Linux kernel. Now we need to understand what we are talking about. So we need to understand resource requests and limits. So resource requests and limits are used on a per application basis. Then there is also this thing called quota, and quota are enforced on a project or cluster basis. So the thing is, you can tell an individual pod, hey, this is what you can use, and you can tell a project or a complete cluster what is going to be used. So basically, in order to understand what we are doing here, you need to understand that there are 3 different levels that we are working on. Well, strictly speaking, even 4 different levels. So we have the level of the container as the lowest level. We can apply to the pod, we can apply to the product, we can apply to the cluster, and we can modify the template. And the template is something that is going to be used when you create new projects. And from the template, settings are applied to everything that you are doing in that specific project. So we are starting at the branches, at the pods and the containers, and from there we will move our way up so that you will learn how to apply it cluster-wise. So third bullet on the slide, in pods, spec.containers resources .requests. A pod can request minimal amounts of CPU and memory resources. And then there is the scheduler. The scheduler is going to place your workload, and the scheduler will look for a node that meets these requirements. And in pods, spec containers resources limits, the pod can be limited to a maximum use of resources. So here is an important thing to realize. We have a request and we have a limit. The request is the minimum. The limit is, well, the limit. So that is the maximum that is going to be used. And in order to implement that, C groups are used, Linux kernel C groups. That's just nice to know. That is not important at all. So how are we setting resources? Well, you can use OC set resources to set resource requests as well as limits, or you can edit the YAML code directly. If you plan to do the exam, then I would advise you with the exam in mind, focus on OC set resources because you can use OC set resources -H, and -H is giving you help, which will make it easier. Resource limits or resource restrictions can be set on individual containers as well as on a complete deployment. We just talked about it. And how do we do that? Well, we do that using commands like OC set resources, deployment, hello world, Nginx, -- request, CPU is 10M, memory is 10 MI, limits CPU is 50 M, and memory is 50 MI. In case you are wondering what is CPU is 10M, 10M, that's a millicore. A millicore, that is 1,000 of the capacity that is offered by a core. Welcome back, Andre. I'm glad that you made it back to this class. Yeah, as I was just telling you, if you want to do the exam, OC set resources -H is useful. So what are we going to do? Oh no, we might we might reach a point where there's a swear word somewhere in my YAML code. I'm sorry, but I've never removed it. I know there's a swear word somewhere. We will see. I am going to use first. I'm going to pop up the right slide, and then I'm going to use the right interface to have you participate in what I'm doing. So here we are. I'm starting OC create deploy. Nee, minus image is bitnami slash nginx latest. What I like about the bitnami images is that you don't have to do anything with service accounts, because bitnami has created a couple of container images that are rootless, so you don't have to configure anything to have them working. Minus replicas is 3. Oh, is that so? OC minus version. I am probably.
You first create it, then you scale it.
If I have the latest version, then I should be able
Create.
minus replicas is 3. When you start your Openshift, it's telling you to do something in order to get access. As you can see here, I'm on the client version 4.5 and I'm on the server version 4.6.6. And this is just annoying me. I know that your solution works, Andre, and I know that I can use it as the easy way out, but now I just need to know for myself, where did I put my stuff? Stuff, where are you? Stuff, there it is. I was looking for this login.txt. Oh no, that's only the login.txt. What was it again? The OC, and well, never mind. Andre, I'm going to listen to what you are suggesting. Let me create it. And let me also use OC scale to scale it up. You know, Kubernetes has a new release every three months or so. And if I remember it right, I think it was 1.18 that suddenly OC create deploy supported minus replicas option. My client is in Openshift 4.5, and it's probably based on a Kubernetes version of 1.17 or whatever. OC skill deploy. Nee, minus replicas is 3, should do it. There we go. OC get pods, and there we go. We have our pods being created or used. Now I am going to use OC get pods once more, running and OC set resources. Just set resources -8 so that you can see that there is some reasonable information in the output of the -8. So here is how you set the resource. Also remove the resource request. It's interesting. You don't delete it, and you set it to null. And yeah, but let's continue on the OC set resources. Deploy, nee, minus request. Request with an S. CPU is 10M. Memory is 0.1 MI. Minus limits. CPU is 20 M, and memory is 0.5 MI. And OC get pods. And what do we see? Oh, we see that it's creating a new pod. And this new pod will be stuck in a state of container creating. And if we use OC describe, I think you are right, yes. OC describe pods on nay whatever, nay which, nay 58 whatever. There we can see pod set memory limit, to loads, not happy with the memory limit. So that's exactly what I wanted to do. And you are right, and I should have updated my slides. The 0 dot does not work. But we can see that even if the 0 dot doesn't work, it does face the memory limit and it can start. Now I want to set it back to all zeros, because that would make it even a little bit more interesting. So there we can see that the requirements are updated, and OC get pods is showing us what? Well, we can see that this thing is in terminating state, and it's in creating state, and I expect it to be out of creating state pretty soon. There is one thing though, and I would love to hear your opinions on that. There's one thing that now I see. I wanted to say there's one thing that I don't understand, and that is why it is suddenly in a container creating. Well, it's suddenly in a container creating because apparently it's applying updates to these new pods. And once it is done, we will have all new pods. Right. Let me do a quick fix on the slide, because this demo is more efficient if we remove the dots. And it's also interesting if we reset at the end using these zeros. In the EX280, you will need to do troubleshooting as well. And one way of doing troubleshooting, they will bring you in nasty scenarios. And I would not be surprised if they bring you in a scenario where you can't run resources because of resource limitations. In exams, I always have the non-disclosure agreement. And I'm trying to be fair with the non-disclosure agreement. I don't want to bring exam questions because it needs to be worth something, right? But I want to make you aware of stuff. There's a lot of troubleshooting in the exam, and resource limitations, limits, and that stuff is very, very important in the exam. And if you want to know, how do I know? Of course, I've taken the exam. And if you want to know, did you pass? The answer is a big fat nope, I did not. I'm going to do it again. But being a courseware developer, I like failing my first attempts on the exam. I also like passing the first attempts on the exam. But I'm so happy that I can take the exam again and filter out some other nasty details. Hey, about taking the exam again, as I was telling you, I want to do an exam training. And it happens to be that I have EX280 on my schedule for February 23rd. Everybody, pencil it into your agendas, either February 10th or February 15th. Same times, I'm going to host this exam training. That was slightly off topic. Right, monitoring resource availability. This is interesting as well. If you use these commands, and look at the slide for yourself if you want to, but if you use these commands, OC describe node on your node name, then you can get information about resource usage. Kind of interesting. Apparently, we still have somebody running with a resource limitation of 512 megabytes. You can also use OC ADM top, and OC ADM top is awesome. but it requires your node. No, it requires metric server to be running. You get this error here: server could not find requested resource, get services, blah blah blah. That is because it requires metric server to be installed and configured. That's not something that we have done in this class, and that's also not something that we should be worrying about. I would like to do another break. And after the break, we are going to continue with quota and resource limits and such. This time, I would like to have a normal break. Let's do 10 minutes. I think 10 minutes sounds reasonable, isn't it? Let me get back to the Git repo. Start the timer again. Don't we have a timer in here? Oh no, I'm not doing my O'Reilly timer. I am doing the GoToTraining timer. So folks, I will go on mute. I start my timer and I see you in 11 minutes and 57 seconds, or maybe a few seconds earlier. Going on mute now. And it's time to continue. Let me open my stuff. Where were we? Yeah, we are going to talk about quota. Let me get back to the slides a little bit. And let me also close the timer. There we go. So applying quota. So what are quota? Well, quota are used to apply limits. And you can put limits on the number of objects, such as pods and services and routes, but also on compute resources, such as CPU and memory and storage. And quotas are useful for preventing the exhaustion of vital resources like the etcd, IP addresses, and also compute capacity of worker nodes. Quotas are applied to new resources, but they do not limit current resources. That is definitely something to remember. And to apply quota, the resource quota resource is used. And you can use a YAML file or you can use OC create quota. And OC create quota, and that's again your exam tip. If you are going to use OC create quota, at least you have -8. And -8, as you can see right here, is giving pretty decent example of what your code may look like on the exam. Okay, so quota scope. Oh, I just realized that you can't see my OC create quota -8, but you can do that for yourself. I'll switch to demo mode again in 4 slides. So there are resource quota. Resource quota are applied to projects to limit uses of resources. So they are applied to projects, okay? A resource quota is really about the availability to create stuff within a specific resource. That's also something that you should worry about when trying to understand all of this. There are things that are applied to the pod. There are things that are applied to the projects, and we are talking about the projects right now. And before we were talking about the resource limits, and that was by using OC set resources. So OC set resources is what you apply to your pods and your deployments, and resource quotas and even cluster resource quotas apply quota with a cluster scope. That is what you apply to a whole bunch of projects. You can even apply multiple resource quotas to the same project, and they will be added if you do that, and limit one specific resource type for each quota resource that is used. And yeah, exam tip: use OC create quota -8. Avoid using YAML. Hey, this is just a thought that I have about OpenShift coming from a Kubernetes background. In Kubernetes, it is promoted very much to use YAML, you know, the declarative versus the imperative way of working. And using YAML, that's a holy grail because it's the DevOps way of working. In OpenShift, they are providing quite a few tools to make it easier for you to avoid using YAML. And I kind of like that, to be honest, because how on earth are you ever going to apply decent working YAML files on your exam when there are so many options? Right, verifying resource quota, you can use OC get resource quota for an overview of all resource quota API resources, and you can use OC describe quota, and that's a very interesting one to show cumulative quotas from all resource quota in the current project. I'll show that in a bit in the demo. Now, you should also understand quota related failure. So how does that work? Well, if a modification exceeds the resource count, like the number of pods, OpenShift will deny the modification immediately. That's easy. If you have a pod limit of 5 and you try to go beyond, as we have just seen in my previous demo where it was unattended, OpenShift will fail. But if a modification exceeds quota for a compute resource, OpenShift will not fail immediately, and that is to give the administrator some time to fix the issue. And if a quota that restricts usage of a compute resource is used, OpenShift will not create pods that do not have resource requests or limits set also. And that is also important to realize. It's very nice to set quota, but in order to have your quota on your projects working, your pods need resource requests and limits. And that is kind of weird, but that is definitely something to keep in mind. And it's also recommended to use limit range to specify the default values for resource requests. Now it's time for a demo, and the demo is on the next slide. This is the demo that I am going to run for you, and let me do that from the terminal. Terminal, where are you? Terminal is right here. Oh, terminal window. Terminal window. Good. So what are we going to do? Well, we are going to log in as user developer. No, I'm confused. Developer is the password. Yeah. Slides is wrong there because I'm using the default developer account. Slides are assuming that you have created users and RBAC in lesson 5 and lesson 6. Now OC new project quota test and OC login -u admin. No, I need my cube admin here. So Control R cube, there we go. And as cube admin, I can set resource quota. Okay, there's RBAC involved. Ordinary users can't do that. So OC create quota. Quota, how hard is it to type correctly? Qtest, -hard. Pods is 3. CPU is 100. Memory is 500 MI. Good. OC describe quota is showing the current quota. And what do we see? Oh, that's interesting. We see that I have 2 different quotas. So I have quota test and I have Qtest. And both are on quota test. Haha, that is funny. This is one of the old quota that still is around from development. So OC delete quota test quota. And let me do another OC describe, and there we can see that we have one quota only. Good. Back to the developer shell. And let's do, excuse me, let's do OC create deploy on bit Nginx -- image is bitnami Nginx :latest -- replicas is 3. Oh, there we go again. That is this little issue, not important enough to fix it right now. So OC skill deployment bit Nginx -- replicas is 3. That will do what I want to do anyway. And now OC get all. And there you might be in for a surprise. Unfortunately, the slide is already spoiling the surprise, but we are... Oh, that's unexpected. I was expecting there to be no pods. And I'm wondering what is happening here. The thing is that no quota have been set on the deployment, and for that reason we should not be able to create the pods. Is this some roaming configuration still around? I think it is. Is this interesting enough to fix right now? No, I don't think this is interesting enough. I think there are nastier things that we should be talking about. So, hey, please remember, if you do this in a clean environment, I would be interested in knowing if you've done it in a clean environment and the behavior that you get there. If you do this in a clean environment at this point, you should see that no pods are created. Because in order to create resources, the resources must specify quota as well. So that will be OC set resources deploy bit Nginx -- request CPU is 100 M, memory is 5 MI -- limits CPU is 200 M and memory is 20 MI. What's going on here? OC set resources -- help. I typed -- help. That's so terrible. Hey folks, if you look above the line that I've highlighted here, OC set resources deployment Nginx -- limits. Oh, we are missing no, we are not missing an equals. It should be doing without the equals. And a request CPU is 100 M. And did I make a very stupid typo here? OC set resources deploy bit Nginx. Yeah, I made a very stupid typo. Request without an S. Hey folks, are you still alive? Yeah, Henry, affinity taints toleration.
We're here.
You are here. Good. Thank you very much. You are so quiet. And you know, I don't want to be a sad person sitting in a dark room talking to his computer screen. I want to be a happy person working together with in a little group of 8 people where everybody understands what I'm talking about. So please help me in being a happy person. Thank you very much. Or grazie mille, to say it in Italian. We have Paolo from Italy. Haven't heard much of you, Paolo. You still here? Right. That might be... No, that's Henry. Como by. Did you Google Italian, Henry, or are you this language miracle person? Right. Whatever. I am going to talk about limit range now. Food, yeah. Food is what it's all about. With a nice glass of wine. I'm doing dry January. So I absolutely don't think of drinking beer and wine and whiskey all the time. Oh yeah, Henry. Wine in Cape Town. I know all about it. Henry, that is totally off topic, but I do like sparkling wine. Any recommendation for South African sparkling wine? My wife is from France, so she always wants to drink champagne, and I always try to bring in some sparkling wines from wherever. If you have any tips on that, please post. And regardless, thank you very much, Henry. I will continue and talk about limit range. So, what is limit range? Well, limit range, limit range is a resource, and this resource defines a default and minimum and maximum values for compute resource requests. Limit range can be set on a project as well as on individual resources, and it can specify CPU and memory for containers and pods. And limit range can specify storage for image and PVC. And if you want to apply limit range, then you can put it in a template. Now, what is this template? This template is, well, a template that can be used to apply limit range and many more things to any new project that is created from that moment on. And the main difference between a limit range and resource quota is that limit range specifies allowed values for individual resources, where project quota set the maximum values that can be used by all resources in a project. So that is really important to realize. So limit range is like what we have seen. The resource limits that you specify in the pod specification. So you have pod spec containers resources request and pod spec containers resources dot limits. That is something that you can set in individual pods, and then we have limit range, and limit range is what you are going to do for all of them. Let's do a demo creating a limit range. And Andrea, if at the same time you can be more verbose in your question and type that in the chat, I would appreciate, because I'm not sure I understand what you want to say here. But let's get back to the demo. Here we are. So I am going to use OC-get projects, doing a little bit of housekeeping. Looks as if I'm the developer and I want to be the big fish. So let me use OC delete NS limits. The thing is, you create a project and you want to clean it up, you need to clean up the limit. The namespace. And let's also OC delete quota test. This is me patiently waiting. There we go. And let me use OC explain. OC explain on limit range.spec. So what do we see in the limit range? Well, you can see that in the limit range, there is only one field in the specification, and that is limits. And there you can see what the limits are like. So we have a default request, we have a max limit ratio, we have a min, and we have a type. Now, in order to create it, OC create, just doing an OC create. Can we do limit range in an OC create? That's the unfortunate thing, we cannot. So we need to work with some configuration in a YAML file. So let's have a look at limits.yaml, where we can see what it looks like. And it looks ugly, doesn't it? I mean, in the spec you can see the limit, and the limit applies to all these different types, and for each of these different types you specify what you can do. But dude, how are you ever going to do this on the exam? I'm still looking for the golden solution for that, because I don't think it's obvious to get from OC explain to the contents of what you can find in this limit range YAML file by default. And as far as I'm aware, Openshift also does not create anything automatically. You know, when I'm developing courseware, I'm always looking for things that make it easier to do this thing on the exam when you are so stressed that your brain has shut down and you can hardly access that information anymore. If you have any suggestions, please tell me. If not, I will just continue. What do we see? We see metadata. Metadata is set to a name. That's not interesting. Then we have the limits, and the limits apply to the type pod with a max and a min, to the type container with a maximum and a minimum, and even a default and a default request. So we have the type OpenShift image. So we set that to storage of 1 gigabyte, and image stream and persistent volume claim we see a little bit more. Now that I say so, I want to investigate spec.limits, and in spec.limits I want to see the type. Just curious. I'm trying to figure out a way to get the information visible on the exam, okay? Because on the exam, you have a weird brain if you can remember stuff like this. I can't remember stuff like this. So I want to see if in limit range.spec.limits.type we can see the types. And I'm also curious about the difference between the default and the default request. So limit range, spec, limits, type, and anything. So OC explain limit range dot spec dot limits to start with. We've been there already, but I like seeing the different options. These are the options that we are working with. So first thing I want to see is type. And in type, that's unfortunate. Type of resource that this limit applies to. So really you need to be creative there. OC explain is not going to help you. And Andres, maybe this the documentation that you have copied here, maybe that's going to be helpful. But Andrew, you are saying you can OC patch with JSON path, but yeah, is that going to make it any easier if I need to do it on the exam? That is what I'm wondering. I'm not so sure about that, unless you see a way that I don't see. Here we can see default, so that's an interesting one. So at least we have some description here, right? So default resource requirement, limit value by resource name if resource limit is omitted. So that is a default limit, and the other one is default request. And there it says default request is default resource requirement request value by the resource if the resource request is omitted. Okay, so we have a limit and we have a request. And to set a limit, you use default, and to set a request, you have default request. And the rest of it is just explanation on how to use it, but hopefully you've done that before. Once you go to the exam, of course. So back to the limits.yaml. So what do we see? We see that we have a maximum, we have a minimum, we have a default limit and a default request. Typically the limit is higher than the request, and that seems to be looking all right. I'm just scanning through it to see if I see anything that's weird. I don't think we see anything weird. I think that is kind of okay. So let's use OC create -f limits.yaml. And quota test namespace not found. Let me fix that. That is interesting. Look at that. I have name limits. I'm confused here. I'm trying to create a limit range, and it is complaining that the quota test namespace is not found. Not sure why that is happening. Did you see quota test in the limits YAML? Well, grep can read better than I can. So grep quota test on limits.yaml. I don't see it. OC projects. And I have no idea where it is getting this quota test from. That is weird. OC get events. No resources found in quota test namespace. Yeah, I know. This makes
Type
me
OC
want...
project?
Sorry?
Type OC project? Right.
OC new project quota test. It's telling me you don't have rights to view project quota test specified in your config. What might be the case here, I just cleaned up, right? And I cleaned up after logging in. Maybe I cleaned up the project that I currently was in. That's the only thing that I can imagine here. And OC, who am I? Yeah, I'm kubeadmin. As you can see. I'm just going to try to apply the limit range again. Andrew, of course you are allowed to talk, but if you don't want to talk, can you close your microphone, please? So that was an interesting one. But OC create -f limits.yaml, it is now applied. So it looks as if I cut off the branch on which I was sitting. So OC get limits range is showing that we have the quota test limits and we have limit limits. Now, what did I just create? I created limits. So that is good enough. But to make sure that we are not going to be confused, I am going to use OC delete limit range quota test limit. There we go. And OC describe limit range limits is showing the current limit range, and that's convenient as well, so that at least you can see what it is doing. So do we see anything interesting in here? Hey, I'm just wondering. Let me first check if I have anything depending on this limit range later. I'm still looking for some way to cheat out this limit range on the exam. Right here we can see OC describe limit ranges, okay? And that works. Now, what happens if I do an OC delete limit range limits? There we go. And an OC create. No, I can't create a limit range, of course. Just wondering, OC describe limit ranges, is that going to show me these fields, yes or no? No, I was just wondering if maybe we can cheat our way and find the appropriate fields here, but it really looks as if it is using the fields that were defined in my limit.limits. So never mind, and let's get back into the limits.limit, and we now have a limit range that is setting these limits. All right, what is the next thing that we are going to do? Henry, nice YAML code. Why? Bad copy. Okay, I will let you finish. I do have the impression that you want to say something useful.
Sorry, yeah, I was just looking in the reference material. But yeah, no, sorry about that.
Okay, no problem. Everybody, did I already mention that if you are going to do the exam, on the exam you get access to the documentation. The inconvenient thing is that they are providing PDFs with all the different sections of the documentation. So you really need to know in which section of the documentation to find which kind of information. There's no real search engine because, well, I was prepared for the exam, the Ansible exam way. There you can search. There you have a real mirror of the exam HTML. It didn't work out too well for me, but maybe if you're prepared on documentation, which section of the documentation contains what, maybe that works better. Okay, I'd like to go back to the slide specifying quota range. So what is this about? Well, this is about how to specify quota range. So the cluster resource quota resource is created at the cluster level, and it applies to multiple projects. And administrators can specify which projects are subject to cluster resource quota by using Openshift IO requester annotation to specify project owner in which all projects with that specific owner are subject to the quota. And also using a selector and labels. If you do that, all projects that have labels matching the selector are subject to the quota. And that is selector and labels in the same way as you have seen it throughout on many different resources. Now, what does that look like? Well, this is what it looks like. So you can see an example that will set a cluster resource quota that applies to all projects owned by user Linda. So OC create cluster quota user Lisa. There's project annotation selector Openshift IO requested is Lisa, hardpots is 10, secrets is 10. I'm confusing Linda and Lisa here. Let's fix that. And the second example will add a quota for all projects that have label env is testing. So OC create cluster quota testing. So in here you create a cluster quota resource. And in this cluster quota resource, you set project label selector and vis testing. Hard pods is 5, service is 2, and then OC new project, test project, and OC label NS new project and vis testing. And that makes that the cluster quota applies to this new project. I think that is something that deserves a nice demo as well. Excuse me. Let me wipe my nose and shut off the sound. This came so unexpected. And I am back again. So what are we going to do? Well, we are going to create cluster quota testing -- project label selector, env is testing -- hard pods is 5, service is 2. Yeah, I can imagine that. There we go. And what is happening here? Oh, I can see. We need a comma. Okay. Just taking a guess here. Yeah, services in plural. Let me fix this. It kind of makes sense, right? Everything is plural, including the services. So OC new project test project test project 2 OC describe quota and that is showing us test project 2 quota namespace test project and resource, and we have a hard and a memory of 10 gigabytes and a pod, which must be coming from my template quota. I didn't want to do that, but it's a little bit confusing. We will talk about the default template and how you can apply quota and limits in there later. But the thing that you should see here is that this does match the pod limit that is set to 5. It doesn't show anything about the service limit. And by the fact that it doesn't show the service limit, I think it's fair to conclude that the cluster quota testing that I just created does not apply. So let me use OC label NS on what? On new on test project 2. Env is testing. And now if we use OC describe quota again, I still can't see it. That's not what I was expecting to see. Okay, failing demo. I think this is the first hard failure today, isn't it? I think also that we should be talking about default template, because hopefully by exploring the default template, we will also understand what is going wrong here. Before continuing, I need my fresh cup of coffee, everybody. So I'm going to put on the timer once more for the last time today for another break. I see you in 12 minutes. I go on mute now. And one last time, hello everybody. Time for the last 40 minutes or so in this class. So what are we going to do next? Well, we are going to talk about the quota range. We already talked about quota range. We need to talk about the default templates. So let's do that. Where are we? We are not on the slides. Let me get to the slides. So default template is what this is about. So what is a template? Well, a template is an API resource. It can set different properties when you create a new project, like quota, like limit ranges, like network policies, and more. In order to create a template, the recommended way is to use OC-ADM create bootstrap project template -o YAML, and redirect the output to mytemplate.yaml. That's a YAML file, and you can further modify the YAML file. And then you can add new resources under the objects, specifying the kind of resource that you want to add. And next, you can edit projects.config.openshift.io/cluster to use the new template. So the template is basically a YAML file that you are going to apply at a cluster level. And that is what we are going to do in this next demo in this lesson. Looks as if we are going to have some time to talk about node selector as well. So we'll go there in a little bit, but first let's see if we can get this working successfully. So back on the demo machine, and on the demo machine, I'm going to start with OC who am I, which is showing that I'm kubeadmin. Now I have this thing called limitrange.yaml. There we go, and limit range is of the kind template. Now what do we see in the kind template? We see that apart from API version kind metadata, it has objects, and in these objects excuse me, we can see the different objects that are available. So here we have the kind project. Here we have the kind role binding. Here we have the kind resource quota. And if we go further, then we can see that in the resource quota we have a spec, and the spec is setting a hard limit CPU 3 and memory 10 gigs. Then we have a limit range also through the template, and you can see that the limit range is CPU 30 and memory 30 megabytes. So this is pre-populated already a little bit. Now, pre-populated might not help in the best possible way, so let's also have a look at OC-ADM create bootstrap project template -h. As you can see, the -h option does not have very much useful stuff here. So I am going to use -o YAML to generate the YAML, and redirect that to /blah white slash just to blah.yaml. Then if you look at blah.yaml, you can see what it looks like by default. So in the default, you have a project, you have a role binding, and that is about all that you've got. So how are we modifying the project template? Well, let's get back to the example in limit range. And in the limit range, you can see that we have added the resource quota, we have added the limit range. And well, that means that you need to be able to specify all of these. And I am just wondering what is going on here. Because, you know, I was mistaken. you can see the API version applying to the project and applying to the role binding. So these are part of the template. I'm confused. No, I'm right anyway. I was confused by the indentation, and the indentation is just a list item. So no worries, this is okay. And resource quota really is a part of the template. I was just confused by seeing kind and metadata and spec and API version, and I was like, what? That's normally at the top level of a YAML file, but in this case, as it is a template, it's embedded in the YAML file. So we are good here. Now, the template has a name, and the name is project request. Now we are going to use OC-edit projects.config.openshift.io/cluster. So where does that bring us? Once we are granted access. Oh, how terrible. Do you see that? I can't do that. I'm sorry. Export editor is user bin vim. I mean, come on. Nano. Get out of here. Can we have a real editor? So what do we see? We see that we are in the project. And we are basically in the cluster definition, and in this cluster definition we need, well, here it is, cluster, project cluster. We need to specify the specification, and the specification, this has been pre-configured in my environment, not in your environment, I guess. You can see project request template is already set to name project request. And these 3 lines make that the template is applied to the entire cluster. Maybe it's more interesting if I'm going to do a little bit of modification. Let me use limitrange.yaml and let me create it as new project. And let me also change a couple of settings. So spec CPU, let's make that 4. And memory, let's make that 9. And limit range, I can live with the 30 megabytes. 30, that's a default request, so that is okay. But let me change it anyway so that we can see that it's something different. So 40 and 40 and 4, and well, let's go for 4 all the way. And then what is the name? The name is new project. Yeah. Do I like that name? I don't even like that name. New template. Oh yes, Robert, that is something so important. You know, Robert, I will never take anybody serious as a Linux professional if they start working with Nano. Get out of here. That's not possible. I mean, how can you program Nano in a decent way? And where is the set-like functionality? Right, back to the OC edit. Now I've been chatting so much that I totally forget what I'm doing. New template, that's what we are doing. So OC edit on the cluster. And all the way down to replace this with new template. There we go. And now we should watch OC get pods -n OpenShift API server. And here we should watch, we should wait for about 2 minutes. The idea is that we just, there we go, do you see it? It's terminating and a new one is pending. Because a new template has been applied, the API server needs to fetch the new template, and in order to fetch the new template, it needs to restart. And that takes a little bit of time. 2 minutes is reasonable. And we really need to sit it out. So now we have time for any bad jokes or whatever. Hey Santos, when are you going to do EX280? Or even better, hey Robert, do you think you can beat me in EX280? I don't have it yet, you don't have it yet. Let's see who is first.
I don't think so, but I'll give it a try.
Oh yeah, I would be so proud if you can beat me on that.
Yeah, it would be interesting.
Because, you know, I'm the old guy, you are the talented young guy, and at someday the young people are going to be faster than the old folks.
But it depends on the experience. You have all the experience.
Well, to be honest, in Openshift, I don't have that much experience. What helps me is the Kubernetes experience. I've been doing Kubernetes for a long time, but Openshift is going so much beyond Kubernetes. If you get into the administration side of it, that I'm really not sure about it. Look, our API server is up and running again. Let's have a look at what this is doing. I am going to use OC new project. My new project. And what? I get it. Everybody, you see what's going wrong here? In case you don't, OC
Naming things.
-f limit range dot YAML. I told my cluster to use this new template, and I didn't create the new template. So is it so cool that this is automatically going to work? Maybe we need to do something. OC get pods -n Openshift API server. That guy is running, and you know what?
Did you edit your template?
You want me to edit the templates? Why?
No, I said, did you edit the template? Because previously you were looking at what name you should call your new template.
Yeah.
So now it's referring to that. I'm not sure if it created that.
I never created it. And that's what's wrong here. Now, the challenge I'm facing right now is that I have already told my cluster to use the template. And then I go change the template, and the cluster doesn't get that. That's also not a matter of time because it's telling me, hey, new template not found. So what I want to do, I want to kick the API server. OC delete -n. Where is API server? It's in Openshift API server.
Yeah, server.
And API server, what's that? I'm not sure what it is, but let me just copy it from here. Oh, it doesn't have the resource type. API, oh, stupid me. I like making this error. OC delete without specifying the resource type. This is going so much better. Of course, deleting an API server pod is serious business, but it's only an API server pod, so it shouldn't be too bad. And if I bring down the entire cluster to its knees, then, well, this is the time of day we can do that.
I'll congratulate you if you manage to do that. API server is what the client talks to.
I think it's just a matter of time, don't you think so?
I definitely think so. The deployment config will recreate it.
Exactly.
That's or the deployment,
yeah.
You should have maybe have a look at OZ rollout status and maybe rolled back to a previous revision of the DC.
Yeah, that might be the case. But hey, we are stuck on OC delete, and well, OC delete on API server. I think API server is important enough to give. Oh, there it is. I wanted to say it's getting 2 minutes. I give it 2 minutes.
Yeah, there you go.
But it's already there. OC get pods, and oh, look at that. We already have a new one. So OC new project, that should be working now. It would be frustrating if it doesn't. That is frustrating, it doesn't. So that is annoying. OC get, but hey, a little bit of troubleshoot. That's not annoying, that's fun. So let's do a vim on limit range.yaml. What am I looking for? I'm looking for the kind template. OC get templates. -a, it's probably, that's a lot. And test project, new template and project request. So test project has project request and new project has new template. Now I'm just wondering, OC API resources, grab template. I want to know if this is, I was expecting this to be non-namespaced, and now I see namespaces, so not sure what's happening here. And there we can see that apparently templates are namespaced. Okay. Now let's see if we can set it back to project requests and then to new templates. I think that's the only way. I'm a little bit disappointed that it doesn't pick it up automatically. OC edit, right? OC edit and project request. So where was my new template beyond all these managed fields? And then, don't know how smart this is. New template. And then we can go do our watch again. Terminating and pending, that is like 18 seconds. I'm not sure what to think of the terminating. That is 4 minutes, 18 seconds old. Maybe we do need to revert an operation on the daemon set. You said it's daemon set, Henry, the API server? I think you are right, but we will see. And we will also give this 2 minutes or so. It would be an interesting kind of troubleshooting. Oh, there we go. Out of terminating. and back in initializing. If this is not going to work, then I think we are going to do something else anyway. Oh, Andrew has internet problems. I think Andrew is on 3G right now. That's probably not easy. Right, what did I want to do? I wanted to create a new project, right? And it's still complaining that new template is not found. Everybody, I'm going to stop this demo because I really feel I messed it up and I need to take some time to get back all the way to the beginning. That would be the remaining time that we've got, and instead of spending a lot of time on this demo, well, I'm just going to talk about something else. Andrew, I'm not sure if you can still hear me, but if you can, it was awesome having you here. And thank you very much. You've shown that you know your stuff, and I much appreciated your involvement and your participation. So, yeah, likewise, I'd be happy to join you back in upcoming sessions. I will always extend a free invitation to the good people. Well, free, that's relative, right? Donate for either Diergaarde Blijdorp or Living Open Source. Right, everybody. I would like to talk a little bit about the parts that are in the beginning of this lesson. I want to fill up my entire 20 minutes, so we can talk a little bit about pod placement and try to understand how that is working, because that is giving some insight in the scheduler. So 3 types of rules are applied for pod scheduling, and these are node labels, affinity rules, and anti-affinity rules. And the pod scheduler, when it is going to schedule a workload on a specific node, always works through 3 steps, which are the node filter, node prioritizing, and select the best nodes. So in the node filter, it will check node availability, but also selectors and taints and resource availability. You know, taints that is like do not run or whatever. Node prioritizing, that is based on affinity rules, something that we haven't talked about here. And you can consider yourself lucky that we haven't done that. And then it's going to select the best nodes based on the outcome. If necessary, it will do round robin. When using a cloud, and that's interesting as well, scheduling by default is within the boundaries of a region. So you will never get beyond the region. Just as a reminder, we are very focused on the code-ready containers here, but it appears that most OpenShift users are using OpenShift in a public cloud environment. Right. One way to determine pod placement is by using a node label. So nodes can be configured with a label, and a label is an arbitrary key value pair that is set using OC label. And next you can use the pod, and you can configure the pod with the node selector property that is on the pod, so that they'll only run on the node that has the right label. So how do we do that? Well, we set the label using OC label, and that's kind of boring. So no need to talk about that. There's also this thing called machine sets. Now, what is a machine set? This is in lesson 9. That is totally irrelevant, but I haven't included lesson 9 in this pre-release. But lesson 9 is about automatically scaling up and automatically scaling down the cluster. So if you have full stack automation, you would be using OpenShift in a public cloud environment, and OpenShift would automatically scale up and automatically scale down based on specific criteria. And in order to get that working, you will be using machine set. So a machine set is a group of machines, and you can manage the entire group of machines, and you can set labels on the group of machines. This is interesting to know about, but not for what you need to do for a day-to-day operational OpenShift management. What you do need to know about is the node selector. So infrastructure-related pods in OpenShift by default are configured to run on a controller node. And you can use node selector on the deployment or deployment config to configure its pods to run on a node that has a specific label. Just 2 words about deployment and deployment config. The deployment config is the Stone Age alternative that previously was used for deploying pods. Nowadays, we would be using deployment. If your OC client version is old enough, then you would be using deployment config instead of deployment. Be warned that when I was taking the exam, that the exam was on 4.3, and in 4.3 version of the exam, it was deployment config and a replication, what the thing that came before replica set. Nowadays, that would be deployment. Use OC edit to apply it, and if a deployment is configured with a node selector that doesn't match any node label, pods will show as pending. And you can fix this by setting deployment spec template spec node selector to the desired key value pair. Right, you can also set node selector on projects. So how does that work? Well, if you want to do that, you do something like OC ADM, new project test -- node selector env is test. And to configure a default node selector on an existing project, you can add an annotation to the underlying namespace resource. Kind of confusing in OpenShift that they have these projects that are more or less compatible with namespaces. More or less, that's the right way of saying it. I think we should have a look at the node selector demo. So here is the node selector demo. Might be the last demo of today. We'll see how it works out. There we are. So I need to be developer. So there we go. I am developer and I am in target project. That's okay. OC get all. Just want to see how much trash there is in the target project. And well, a lot of trash, but last demo I'll take my risk. So OC create deployment simple -- image is bitnami /nginx latest. Again, I like using this bitnami image because we don't have the hassle of working with an image that requires root privileges. OC get all should show me the bitnami deployment, if it ever gets out of there, of course. And there we go. We can see the simple deployment. So OC expose SVC simple. SVC no. Deploy. I'm just wondering, why am I exposing? Let me skip that expose. That makes no sense. What we are going to do. I think my demo is beeped up. Okay, no, I understand. Let me just follow along. OC expose deploy simple. We don't need the expose now, I'm sure. That must be a typo, and I don't know what I had in mind. OC skill -- replicas for deploy simple. There it's killed, and OC get pods -o wide, and there we go. And oh, I have one pod running. Why do I have one pod running? I think I know why I have one pod running, because of this resource limitation that says that I can have a maximum of 5 pods in this project. So I'm going to use OC delete deploy nay, and also OC delete deploy Nginx target. I don't even want to investigate, just OC get pods, and there we can see simple is running. I do need OC describe. OC describe on RS simple whatever. 10 seconds created pod and 11 seconds created pod. I think that is the proof that we were looking for. Yes, there we go. So I now have 4 pods that are available, and that's what I wanted. OC get nodes, OC get nodes -L env. I'm developer, it's not going to work. So let me log in as the admin user. And there we go. So OC get nodes -L env. This is showing nodes that have with the column label env. Obviously, there are no nodes that have that label. So I'm going to use OC label node crc whatever. Env is dev. Now the demo continues on the next slide, where I am going to use OC login -u developer -p developer, and then OC get deploy, which is showing simple, and next I am going to use OC edit deploy simple. And then I am looking for DNS policy, because right after the DNS policy, there we go, I am going to put this node selector. Obviously, it can be anywhere in the spec as long as it's at the same level as DNS policy. So here we go, node selector. And in node selector, we said env blah, because that is what we wanted, right? Now, OC get pods. Does this influence the currently running pods? I don't see, well, I do see one pod in a state of terminating and another pod in a state of pending. And if we are going to use OC delete RS simple whatever. Oh, I first need to do an OC get RS, I think. And there we go. There is one guy 2 seconds old and the other one 5 minutes old. So let me do an OC delete RS simple on the 7 one, which is deleting the old one. And then let me do an OC get RS, and OC get RS is showing me what? Well, it's showing me pending and pending and pending and pending. And why is it doing that? Well, it is doing that because it has no matching nodes. Before I forget, please allow me to change my slides, because I did see 2 things that I don't like, and now they are so much better. So yeah, what are we going to do next? OC get pods. We are stuck in pending, right? And if we use OC describe on pods simple whatever, ph for example, oops, pod A is not found, okay, but here we see what I was looking for. 0 out of 1 nodes are available. 1 node didn't match the node selector. Now, how about I use OC label node Control R, label, there we go. So I'm going to relabel the node. env is dev. I'm using env minus. The env minus will remove the label. Okay, I need to be admin. And then I can do the label again. There we go. Now the big question is, does that change anything in the status of the pods? OC get pods. And there we can see that the pods are still in a status of pending. So what does that mean? Well, that means that the scheduler apparently is not smart enough to discover automatically that something has changed in the node label. So if I want these pods to get out of a pending state, then really I need to delete the deployment and create the deployment again. There's one thing that I do want to check, by the way. OC get rs. OC delete rs simple. What happened to my command line completion? There we go. OC get rs, and there we can see 4 out of 4. Oh, we can also see that it still has the same replica set. OC get pods, and this isn't getting it out of the pending state. I am not even going to show you how to delete the deployment, how to create the deployment again. That is really not worth it. This was the last demo of the day, and with that, it's almost top of the hour, and believe it or not, unfortunately, I have other things to do, and Robert needs to get home before the curfew. Robert, I hope you don't need too much time, and traffic in Nairobi at this time of the evening is not traffic in Nairobi as I know it, because in that case, you better run, my friend, to get home before you need to be home.
No, I'll be okay. In fact, I have an Uber waiting for me, so I'll be fine.
Okay, I'm happy to hear that, Robert. All right, everybody. Yeah. It has been a lot of fun working with you today. I hope it has been useful for you, and I hope it's going to contribute to your success in Openshift. Keep an eye on my social media. I'm definitely planning to do a sample exam pre-release in maybe about 4 weeks or so. And I'm also considering to do an OKD installation workshop. OKD installation is complicated, and once I have found out an easy way, then I think that's also a brilliant candidate for an installation workshop. The only unfortunate thing about OKD is that you need lots of RAM, and that's making me mad. But that's the way it is. Everybody, again, thank you very much for attending. I will process recordings, and I will send you recordings. That might take a week, maybe even 2. Processing recordings is typically weekend kind of work. So with that, I just think we are going to call it today. So stay safe, have a nice rest of the day, and bye-bye. I hope to see you soon, everybody.